If a photon of light from 13 billion years ago is still traveling through a forgotten corner of the universe, what does it want to tell us? Its journey began in a cosmos that was still a furnace, a place of first things, before the Earth had formed, before our sun had even ignited from its dusty cradle. That single particle of light carries a memory, a snapshot of a time we can only imagine. The James Webb Space Telescope is a machine built not just of mirrors and sensors, but of a deep human need to intercept that message, to catch that ancient light and decipher its story. And with the first images it has captured, it has begun to shed light not only on the birth of stars, but on the history of our own understanding. What we are seeing through this new eye is anything but ordinary. From galactic collisions that sculpt the heavens to distant planets bearing the chemical fingerprints of life. From explosions of energy that defy the known laws of physics to mind-boggling details about the very first moments of the universe. Everything is contained within these images. This is not just an act of observation. It is an invitation to join humanity in a great and unsettling discovery. A moment when our gaze has truly turned toward infinity. From the moment it began its mission, the James Webb Space Telescope turned the eyes of the entire world toward the deepest, darkest corners of space. However, the first images of the earliest galaxies were not what scientists had expected. The images showed galaxies with a much more advanced and organized structure than anyone had previously thought possible in the early stages of the universe. This single finding revealed, with startling clarity, that all our established theories regarding the formation of the universe and the evolution of galaxies needed to be re-examined. While it was previously expected that galaxies at the beginning of the universe would be complex and chaotic knots of gas and young stars, the impossibly clear images from the Webb telescope showed the exact opposite. Some of these ancient galaxies exhibited an unexpected level of order and complexity, with distinct spiral arms and dense central bulges, structures that should have taken billions of years to form. This highlighted significant, gaping holes in our understanding of the conditions at the beginning of the universe and immediately accelerated research efforts worldwide. This profound surprise rippling through the scientific community has led astronomers to re-examine existing theories with a new sense of urgency. The formation of the first galaxies and the mechanisms of star birth are now being questioned at a fundamental level. NASA's own statements have emphasized the monumental importance of this discovery and the pressing need for further research. Therefore, the first images obtained may only be the beginning and are now seen as a harbinger of much more surprising discoveries awaiting us in the depths of the universe. A universe that is proving to be far stranger and more creative than we had ever dared to imagine. The data streaming back from the James Webb Telescope has revealed results that threaten to overturn our most long-held assumptions about the age of the universe itself. For decades, the scientific community had accepted the age of the universe to be approximately 13.8 billion years, a number derived from precise measurements of the cosmic expansion rate. But the new observations from Webb suggest that the universe may be much older. These unexpected results indicate that our most fundamental cosmological models may need to be re-evaluated from the ground up. The data collected by Webb showed that galaxies that appeared in the earliest stages of the universe may be far older than the standard model allows. In fact, the calculated age of some of the stars within these galaxies is almost older than the currently calculated age of the universe itself. This paradoxical, impossible situation suggests that the calculations regarding the expansion rate of the universe and its beginning, which scientists have been using for a long time, may be fundamentally incorrect. NASA has intensified its detailed observations to confirm this startling situation. Currently, scientists around the world agree that the cosmic microwave background radiation, the echo of the Big Bang, and the measured rate of cosmic expansion need to be reanalyzed in light of this new, contradictory data. If the universe is indeed older than we previously thought, then the Big Bang theory and all models of the universe's expansion rate may require a profound and difficult revision. The depth and significance of this discovery will help us to better understand the true initial conditions of the universe. At the same time, clarifying the true age of the universe is also of great importance in predicting its ultimate fate. If this calculation error is confirmed, even the answers to the most fundamental questions in cosmology may need to be rewritten, and the story of our universe will have a new and much longer first chapter. One of the most shocking discoveries made using the James Webb Telescope was the identification of a galaxy that appears to be significantly older than our own Milky Way. This discovery, which completely overturns the traditional assumptions about the formation of the universe, calls into question everything we thought we knew about the universe's long and complex development process. While scientists had long believed that the Milky Way was one of the oldest and most established galaxies in the universe, this new finding has revealed that this is not the case at all. This ancient galaxy is not only older than expected, but it also possesses a highly developed and organized structure. This indicates that even in the very early stages of the universe, there were already quite complex and mature galaxies, fully formed and settled. Such a finding raises the pressing question of how the vast, diffuse clouds of gas and dust in the early universe could have so rapidly formed stars, planets, and the intricate structures of a modern galaxy. This single galaxy discovery could rewrite the entire chronology of cosmological history. Scientists are now re-evaluating the processes of galaxy formation in the earliest stages of the universe. It is now clear that new theories need to be developed to explain the shockingly early emergence of such old and complex galaxies. The data sent back by James Webb offers entirely new perspectives on the physical conditions that must have existed in the early stages of the universe. NASA researchers are continuing their detailed analysis of this particular galaxy, and examining its structure and characteristics will help us to better understand the violent, rapid, and creative processes that dominated the early cosmos. These findings are likely to continue to make a big splash in the scientific world for many years to come, as we slowly piece together a new and more accurate history of our universe. One of the most striking discoveries made by the James Webb Telescope was the identification of a massive cosmic wall in a dark and previously unmapped region of space. This colossal structure has astonished scientists because it is so large that it could affect the large-scale distribution of matter throughout the entire universe and is a previously unseen type of cosmic formation. Scientists say that this giant cosmic wall fundamentally challenges our understanding of the structure of the universe. There is currently no definitive information about how this massive structure formed, or how it has evolved alongside the relentless expansion of the universe. The discovery of this cosmic wall even calls into question some of the fundamental assumptions of our most basic cosmological principles, such as the idea that the universe is roughly the same in all directions on the largest scales. NASA researchers have launched an intensive and ongoing study to better understand the contents and formation of this mysterious wall. Initial analyses indicate that this cosmic wall is a massive, filamentary structure composed of thousands of galaxies and vast, invisible clouds of dark matter. The details of this discovery could add a whole new dimension to our theories of dark matter and how it shapes the cosmos. If the existence and structure of this giant cosmic wall are confirmed, the theories that explain the large-scale structure of the universe could undergo radical and profound changes. Thus, The James Webb Telescope will have opened a completely new chapter in our long and ongoing quest to understand the universe. Among the torrent of data collected by the James Webb Space Telescope from the deepest reaches of space, an extremely surprising and deeply puzzling situation has emerged. A series of mysterious light signals, recorded by the telescope with incredible precision, have left astronomers in a state of profound shock. The frequency, power, and highly repetitive pattern of these signals do not match any known astronomical phenomenon to date. Scientists are currently unable to determine the source of this mysterious light, and all of our existing theories are now being called into question. These regular, repeating signals coming from the depths of space have reignited the long-simmering discussions about whether we are truly alone in the universe. The highly periodic and structured nature of the signals is seen by some astronomers as potential, though highly speculative, evidence of intelligent life. However, such extraordinary claims are still scientifically weak and require much more data to be taken seriously. NASA has not yet ruled out the possibility that these signals are of a completely natural, though previously unknown, origin. These mysterious lights have begun to be tracked by many different telescopes and astronomy centers around the world. Investigations conducted through a massive international collaboration have confirmed the unusual and artificial-seeming characteristics of these signals. Scientists are now working to develop a wide range of hypotheses about the source of these light signals. Pulsars, neutron stars, or a completely unknown type of astronomical event could be the source of these lights. However, if these signals do turn out to be signs of extraterrestrial intelligence, it would undoubtedly be the greatest discovery in the entire history of science. This possibility could revolutionize space exploration and our place within the cosmos. For this reason, NASA is currently mobilizing all of its available resources to find the source of these enigmatic signals. One of the most exciting discoveries made by the James Webb Telescope was the identification of a potentially habitable planet in a region surprisingly close to Earth. The size of this planet, its atmospheric composition, and its precise distance from its star provide the ideal conditions for life to exist. This single discovery has strengthened the possibility of finding extraterrestrial life more than ever before. Scientists have indicated that the likelihood of finding liquid water on the surface of this new planet is quite high. Initial analyses of the planet's atmosphere suggest that it contains essential components for life, such as carbon, oxygen, and water vapor. This provides strong and compelling evidence that the planet's surface may harbor conditions suitable for the emergence and sustenance of life. NASA plans to conduct more extensive observations in the coming months to study this planet in much greater detail. The James Webb Telescope is now collecting detailed data that will clarify the precise chemical composition of the planet's atmosphere and its average surface temperature. If it is confirmed that this planet is indeed habitable, it could mark the beginning of a completely new era in human history. Such discoveries have the potential to fundamentally shake humanity's long-held perception of its isolation in the universe. NASA is already preparing new space missions to detail the physical conditions of this discovered planet. The possibility of turning humanity's ancient dreams of one day settling on a different world into a tangible reality is now higher than ever. Thanks to this remarkable discovery, among the data sent back by the James Webb Telescope are images of some completely unexpected and violent cosmic events. Massive explosions and intense energy emissions in the far corners of space have prompted scientists to take immediate action. The sheer scale and intensity of these events are far beyond anything previously encountered in known astronomical events. NASA is currently investigating these events very seriously. One event in particular has been identified as a massive explosion on a galactic scale. The source of this explosion is currently unknown, and its energy level is incredibly, almost impossibly high. The devastating effects of this explosion on the surrounding star systems and planets are currently being investigated with great urgency. NASA is deeply concerned that such events could also occur much closer to Earth, posing a potential threat to our own solar system. To better understand these cosmic events, NASA has put astronomical observation centers around the world on high alert. The international astronomy community is now intensively analyzing the events observed by the powerful telescope. The cause of these massive energy explosions could be the collision of supermassive black holes or entirely new astronomical phenomena that are still completely unknown to us. Such unexpected events once again reveal how violent, chaotic, and unpredictable the universe truly is. NASA is continuing its in-depth analysis to determine whether such events pose a direct and imminent threat to Earth. Unraveling the mystery of these events in the coming period will play a critical role in understanding the dynamic and ever-changing structure of the universe. The James Webb Telescope has caused a profound stir in the scientific community by capturing the first clear and unambiguous images of complex organic molecules in the deepest reaches of space. This monumental discovery has revealed just how widespread the fundamental building blocks of life are throughout the universe. The clear observation of these molecules, which were previously only speculated about, has significantly strengthened and accelerated the ongoing search for extraterrestrial life. These organic molecules were found in the massive, cold, and dark dust clouds where new stars and planets are born. The undeniable presence of these carbon-based complex structures proves that the basic materials necessary for life to form are present in almost every corner of the universe. NASA researchers are continuing their intensive studies to better understand the formation and distribution processes of these vital molecules. This discovery has dramatically increased the likelihood that the necessary conditions for life could exist in many different parts of the universe. NASA will now explore more regions of space to analyze the diversity and distribution of these organic molecules in even greater detail. This could lead to even stronger and more direct evidence of life in different parts of the universe. Thanks to this discovery, scientists are increasingly supporting the theory that the universe is, in fact, a life-friendly environment. The existence of organic molecules may indicate that life is much more widespread and common in the universe than we had ever dared to hope. This means that our chances of one day making contact with extraterrestrial life are higher than ever before. The data from the James Webb Telescope has revealed that the universe is expanding much faster than scientists had previously calculated. These shocking results, which have plunged the entire scientific community into a state of deep confusion, indicate that our predictions about the ultimate fate of the universe need to be completely re-examined. The concept of dark energy, which is believed to be the cause of the increase in the expansion rate of the universe, has thus gained a much greater and more urgent significance. The expansion rate of the universe is considered one of the most fundamental parameters in all of cosmology, a value known as the Hubble constant. This parameter plays a critical role in our understanding of the age and ultimate expansion of the universe. The precise data provided by James Webb contains dramatic differences that could fundamentally change the accepted value of this constant. This indicates that the universe is not only expanding much faster than we previously thought, but that this expansion is also accelerating over time. Scientists have now begun to investigate the causes of this unexpected and rapid expansion. Among the leading theories is the idea that dark energy is far stronger and more widespread than we had previously thought. If this theory is confirmed, the ultimate fate of the universe, that it will continue to expand indefinitely and eventually end in a cold, dark state known as a Big Crunch, will gain significant traction. NASA has decided to accelerate new observations in this area to gather more data. Additional observations from the James Webb Telescope in the coming period will allow us to measure the expansion rate of the universe much more accurately. This could completely reshape all of our existing assumptions about the ultimate fate of the universe. This unexpected discovery could trigger a major and long-lasting paradigm shift in the field of cosmology. The James Webb Space Telescope recently made a surprising discovery of a new planetary system with strikingly Earth-like characteristics. The system hosts multiple planets located within its star's habitable zone, and at least one of these planets appears to have conditions that are highly suitable for life. Clear and undeniable evidence of both water vapor and oxygen was detected in the atmospheric analyses of one of these worlds. The sizes and positions of the planets in this newly discovered system provide the basic conditions necessary for life at almost ideal levels. Scientists have noted that the specific molecules observed in the atmospheric analysis could strongly indicate the presence of life forms on these planets. This could go down in history as a very strong and concrete example of the very real possibility of finding extraterrestrial life. NASA is now planning detailed and long-term observations to study the chemical composition of these planets' atmospheres in much greater detail. The James Webb Telescope's highly sensitive instruments can determine atmospheric composition and surface temperatures with an incredibly high degree of accuracy. This new planetary system will be at the very center of space research in the coming period and will give a completely new direction to the ongoing search for extraterrestrial life. If the existence of life on the planets in this system is confirmed, this discovery will be truly revolutionary in human history. NASA is, understandably, very excited about this prospect. Joint observations and research conducted internationally may reveal very important and paradigm-shifting data about this system in the coming years. The James Webb Space Telescope has obtained crucial and long-awaited evidence about dark matter, one of the universe's greatest and most enduring mysteries. During its observations, clear and unambiguous clues about the existence and distribution of dark matter were detected from the movements of stars and gas clouds in distant galaxy clusters. This discovery finally and powerfully confirms the long-held theories about dark matter and significantly deepens scientists' understanding of the fundamental structure of the universe. Dark matter, which has been observed indirectly by astronomers for many years but remains largely unexplained, accounts for approximately 85% of the universe's total mass. The data provided by the James Webb Telescope offers the clearest and most direct evidence to date of the existence and distribution of this mysterious and invisible substance. This represents a major step forward in our understanding of how the universe formed and how it has evolved over time. Although scientists cannot directly observe dark matter, they can clearly see its powerful effects. The data from the telescope determines the speed and movement of galaxies, and this motion powerfully confirms the existence of dark matter. This will now make it possible to map the distribution of the matter that holds all cosmic structures together throughout the entire universe. NASA will conduct more in-depth analyses of dark matter using additional data from the James Webb Telescope in the coming period. This will clarify the details of the dark matter theory and provide a much clearer understanding of how the large-scale structure of the universe was formed. This could represent a revolutionary advance in our understanding of the fundamental structure of the universe. The data provided by the James Webb Space Telescope has shown that our current scenarios regarding the ultimate fate of the universe need to be radically revised. In particular, the higher-than-expected rate of expansion of the universe and the stronger-than-expected effect of dark energy are reshaping all of our assumptions about the future of the universe. The scientific community now emphasizes the pressing need to revisit the long-held theories about the ultimate fate of the cosmos. While it was previously predicted that the universe would expand slowly and perhaps even collapse back in on itself at some point in the distant future, the new data from the James Webb Telescope has completely and utterly changed this picture. Scientists now believe that the universe may be expanding at an ever-increasing rate and could eventually lead to a cosmic-scale fragmentation, a scenario known as the Big Rip. This scenario suggests that the universe could transform into a completely different and unrecognizable structure in the distant future. Research conducted by NASA may reveal further findings that support this new and dramatic scenario. In particular, the data collected by the telescope about the very first moments of the universe is critical to understanding how this expansion will evolve in the future. Scientists are intensifying their efforts to obtain clearer data about the rate of expansion and the true nature of dark energy. With the data that the James Webb Space Telescope will provide in the coming years, our scenarios about the end of the universe will become much clearer and more precise. In light of this new data, the sections of our cosmology books about the end of the universe may be seriously and fundamentally rewritten in the near future. The images obtained by the James Webb Space Telescope have revealed the youngest galaxies in the universe. And these galaxies are not what scientists had expected at all. The fact that these young galaxies are much larger and more developed than had been anticipated has led us to question the most fundamental assumptions of our theories about galaxy formation. This single discovery has caused a profound and widespread shock in the entire field of astronomy. Previously, it was assumed that galaxies in the earliest stages of the universe were irregular, small, and very simple in their structure. However, the Webb telescope has revealed that these galaxies possess incredibly advanced and active star-forming regions. Scientists now believe that much more complex and rapid processes occurred in the earliest stages of the universe than we had previously thought. NASA has begun extensive analyses to understand the formation process and structure of these impossibly young galaxies. These analyses have revealed that the galaxies underwent extremely rapid and large-scale star formation processes. The fact that these galaxies are larger and more organized than expected has raised serious questions about how the diffuse clouds of gas and dust in the early universe could have organized themselves so quickly and efficiently. This discovery shows that the conditions in the early universe were much more dynamic and complex than we had ever thought. The striking data collected by James Webb may necessitate a complete rewriting of our cosmological theories. New research on galaxy formation and evolution in the early universe could change the entire history of astronomy in the future. The James Webb Telescope has unexpectedly discovered organic molecules that could be signs of life on an asteroid within our own solar system. The complex carbon-based molecules found on the asteroid's surface had never been detected so clearly within the solar system before. This astonishing discovery has revealed that asteroids could be potential habitats for extraterrestrial life, or at least the carriers of its essential ingredients. The molecules found on the asteroid's surface contain amino acids and other complex carbon compounds, which are known as the fundamental building blocks of organic life. This finding has significantly strengthened the possibility that life could emerge not only on planets, but also on much smaller celestial bodies. The discussions about the important role that asteroids may have played in the distribution of life throughout the cosmos have now been reignited with new and powerful evidence. NASA is now preparing new mission plans to confirm these signs of life on asteroids, based on the data provided by the James Webb Telescope. New space probes are being designed to collect physical samples from the asteroid's surface. The analysis of these samples could provide a much deeper and more profound understanding of the true origins of life. The importance of this discovery is not limited to astrobiology. It also makes it possible to consider asteroids as potential sources of life support that could be used in future space exploration missions. This could fundamentally change humanity's presence in space and our future colonization efforts. One of the most intriguing discoveries made during the James Webb Space Telescope's deep space observations was the identification of an incredibly large cosmic void in the universe. This massive void is hundreds of millions of light years wide and contains almost no galaxies, stars, or even detectable matter. This astonishing discovery is shaking our fundamental understanding of the large-scale structure of the universe. Cosmic voids have been observed before, but finding an area of this immense size that is so completely and utterly empty was completely unexpected. Scientists are still unable to explain how this massive void could have formed. Its formation may be related to unknown factors, such as the behavior of dark energy or dark matter, which are believed to shape the large-scale structure of the universe. NASA has begun detailed studies to understand the nature of this massive void. The high-resolution infrared observations from the Webb telescope are helping to clarify the interaction of this void with the galaxy clusters that surround it. Scientists are working to understand why this void formed and why it is so starkly different from all other parts of the universe. This discovery may force us to rethink our current models of the structure of the universe. The existence of such giant cosmic voids suggests that we will have to reinterpret the processes of the expansion and distribution of matter throughout the entire universe. The data provided by the Webb telescope could reshape the future of all of our cosmological theories. The new images obtained by the James Webb Space Telescope reveal that the processes of planet formation are much more complex and varied than we had previously thought. The new findings show unexpected structures and complex chemical compositions in the planet-forming disks of gas and dust that surround young stars. This suggests that planets may have formed in ways that are very different from what our traditional theories have described. Previous theories suggested that planets formed through the simple and gradual accumulation of gas and dust clouds orbiting young stars. However, the incredibly detailed images from the Webb telescope show that planet formation involves much more complex chemical processes and rapid, dramatic changes. Unexpected gas movements and complex chemical reactions have been discovered during the very formation of these young planets. NASA's new discovery is triggering a major paradigm shift in the fields of planetary science and cosmic chemistry. We are now forced to completely re-examine how and at what speed planets form. The detailed images and spectral analyses provided by the Webb telescope are enabling us to completely redefine the intricate processes of planetary formation. This discovery requires us to reevaluate our entire understanding of the formation and evolution of planets outside our own solar system. As a result, new theories could emerge that will fundamentally alter our assumptions about planet formation and the distribution of potentially habitable planets throughout the entire universe. The James Webb Space Telescope has detected a series of unusual celestial objects moving at incredible speeds in the most distant regions of the universe. The speeds of these objects far exceed those of all previously observed astronomical objects, raising serious and troubling questions in the minds of astronomers. Scientists are currently unable to fully explain how such extreme speeds could have been achieved, and the situation has put NASA on high alert. Some of these fast-moving objects are observed moving at incredibly high speeds, away from the centers of their host galaxies. This suggests that these objects may be associated with extraordinary and violent cosmic events, such as interactions with supermassive black holes or massive asymmetric explosions. However, this theory has not yet been fully proven. Research is now being conducted intensively using the high-resolution data obtained by the Webb telescope. NASA research teams have begun studying the paths that these celestial objects take and the environments around them to understand why they are moving so incredibly fast. If these high speeds are caused by a completely unknown and new astronomical phenomenon, this discovery could represent a major breakthrough in the field of astronomy. For this reason, scientists are conducting various observation campaigns to analyze these objects in much greater depth. The extraordinary data collected by the James Webb Telescope could help us to understand previously unknown physical processes in the universe. Once the mystery behind these incredible speeds is finally solved, we may gain revolutionary new insights into critical topics, such as the distribution of energy and the evolution of galaxies throughout the universe. The James Webb Space Telescope has discovered the oldest known star, an object that was formed in the earliest stages of the universe. This ancient star, which formed approximately 13.7 billion years ago, is a very rare and precious object that reflects the very first light of the universe. The discovery of this star has generated great excitement in the scientific community, as it may reveal important and long-hidden information about the earliest stages of the universe. The chemical composition and brightness of this ancient star provide scientists with clear clues about how the very first stars in the universe formed and how they evolved. The extremely low abundance of metals observed in the star's atmosphere confirms that it was formed in the very early stages of the universe. From the primordial gas of the Big Bang, NASA aims to conduct detailed analyses of this star to better understand these earliest stages of the universe. Scientists believe that observing this ancient star could finally answer some of the long-standing questions about the first stars and galaxies in the universe. The star's unique characteristics could provide critical information about the distribution and density of matter in the early universe. This information could significantly alter our existing theories about the universe's earliest and most mysterious stages. This discovery by the James Webb Telescope is seen as a major turning point in the field of astronomy, pushing back the boundaries of what is known about the history of the universe. This discovery is considered one of the most important findings in all of cosmological history. The new data from the James Webb Telescope suggests that the overall geometry of the universe may be different from what the scientific community has long accepted. While previous cosmological models have assumed that the universe is almost completely flat on the largest scales, the data from the Webb Telescope shows that the universe may have a different and more complex shape. These new findings are seriously challenging the most fundamental assumptions in the entire field of cosmology. Scientists were able to measure the large-scale structure of the universe much more accurately by analyzing the light data collected by the Webb Telescope. The results suggest the very real possibility that the universe may not be perfectly flat, but instead slightly curved or even closed in on itself. Such a geometric structure could significantly affect the expansion rate of the universe and the distribution of matter within it, thereby altering the ultimate fate of the universe. NASA is now conducting large-scale observations using the Webb Telescope's advanced capabilities to obtain clearer data about the true geometry of the universe. In particular, the study of the cosmic microwave background radiation is critical to clarifying the overall and fundamental geometry of the universe. If they are confirmed, these new findings could be truly revolutionary in the field of cosmology. These new findings about the geometry of the universe could fundamentally change our most basic cosmological principles and our theories about the future of the universe. Based on this new data, our predictions about the fate of the universe could change significantly, and many of the fundamental theories in cosmology may need to be completely rewritten. The James Webb Space Telescope has clearly and directly observed the effects of dark energy, one of the greatest and most profound mysteries in all of cosmology. These new observations, which provide concrete and undeniable evidence of how this mysterious energy is increasing the expansion rate of the universe, have caused a major and excited stir in the scientific community. The effects of dark energy, which had previously only been estimated indirectly through its influence on distant supernovae, have now been observed clearly and directly for the very first time. Dark energy accounts for approximately 68% of the total energy budget of the entire universe. But its true nature remains largely unknown and mysterious. Webb's high-resolution observations have enabled scientists to clearly track the effects of this energy on the movements of distant galaxies and entire galaxy clusters. This marks a significant and historic milestone in confirming the very existence of dark energy. NASA research teams are now using the critical data obtained by the Webb telescope to try to understand the true nature of this dark energy. Questions about how this energy works and how it is able to accelerate the expansion of the entire universe are among the most important and pressing research topics in modern cosmology. With these new and precise observations, our theories about dark energy are growing stronger and more diverse. The clear visualization of the effects of dark energy is an important milestone in the entire history of cosmology. Thanks to these observations, our predictions about the ultimate fate of the universe may soon become much more accurate and reliable. The latest images obtained from the James Webb Space Telescope have revealed that the process of galaxy formation is much different than we had previously thought. Previous theories had assumed that galaxies formed slowly over vast periods of time through the gradual merging of small gas and star clusters. But the incredibly clear and detailed images provided by Webb show that galaxy formation is a much more complex, chaotic, and diverse process. This new understanding has caused significant astonishment and debate in the entire field of astronomy. In particular, the fact that galaxies that formed in the early universe exhibit much faster and more complex structures than had been expected renders all of our current models completely inadequate. The observed star formation rates and the rapid chemical evolution of these early galaxies do not align with our previously accepted models. This new situation necessitates the urgent development of new theories to explain the processes of galaxy formation. NASA scientists are now analyzing the data from the James Webb Telescope in great detail to better understand this different and more rapid formation process. The goal is to clarify the physical processes and the interactions of matter that the galaxies experienced in their earliest stages. This will provide a much more solid and realistic foundation for our understanding of how galaxies are born and how they evolve over time. These new findings will completely reshape our theories about galaxy formation and evolution in the early universe. The high-quality images and spectral data provided by the James Webb Telescope could trigger one of the greatest paradigm shifts in the entire history of astronomy and mark a critical turning point in our understanding of the cosmic evolution of the universe. The data recorded by the James Webb Telescope includes unexpected and massive explosions in star systems that are relatively close to Earth. The immense size and energy of these explosions are deeply challenging scientists' current theories about the processes of stellar evolution. This has become a major cause for concern for NASA and has necessitated a serious and urgent reevaluation of the potential for unexpected explosions in the stars within our own cosmic neighborhood. These sudden and violent explosions observed in nearby stars are believed to stem from causes that do not align with our classical models of stellar evolution. These explosions, which are typically expected to occur only during very specific stages of a star's life, are now being seen at unexpected times and with unexpected intensity. The telescope's sensitive infrared sensors provide the unique opportunity to observe the dynamic processes that are occurring inside these stars much more clearly. This new data could lead to the development of completely new theories that can explain the unexpected and sometimes violent behavior of stars. The detailed study of these types of explosions could fundamentally change our entire understanding of the life cycle of stars. It is also critical for assessing the habitability of planets in nearby star systems and for understanding the potential cosmic risks that the Earth may face in the future. The explosions observed by the Webb telescope could open a completely new and exciting chapter in the fields of stellar science and astrophysics. One of the most striking observations made by the James Webb Telescope was an extraordinary and high-energy explosion that originated from the deepest reaches of space. This single explosion occurred at energy levels that far exceeded anything that had ever been previously recorded, leaving scientists utterly and completely baffled. The cause of this explosion remains completely unknown, but astronomers believe that it could potentially alter our entire understanding of the universe's most extreme energy release processes. The source of this massive energy burst could be a galaxy-scale event, something involving the entire structure of a galaxy. Some theories suggest that the burst is related to the merger of two supermassive black holes or a new type of massive supernova explosion. However, even our existing theories struggle to explain energy emissions of this incredible magnitude, and scientists are now in need of completely new theories to explain this powerful phenomenon. NASA is now analyzing all of the data collected by the James Webb Telescope in great detail to understand the specifics of this high-energy explosion. These analyses will help us to better understand the source of the explosion, the mechanism of its energy formation, and its powerful effects on its surrounding environment. The international astronomy community is also showing intense and focused interest in this extraordinary event, and additional observations from many different telescopes are now being planned. The explanation of this single explosion could be a critical turning point in our understanding of the most energetic events in the entire universe. The new data from the James Webb Telescope has overturned our classical theories about the death of stars. In particular, it has been revealed that the supernova explosions that occur at the end of the lives of massive stars go through stages that are very different from what we had previously thought. This new understanding has caused such a stir in the scientific community that it will require the complete rewriting of our models of star evolution. According to the new findings, some stars release energy in completely unexpected ways at the very end of their lives and undergo complex and dramatic structural changes just before the final explosion. The Webb telescope's precise and detailed observations have clearly documented the unexpected physical and chemical processes that are occurring during the pre-explosion stages of these stars. These complex processes were not predicted by any of our existing theories of star evolution. NASA is now conducting detailed observation campaigns to confirm these unexpected findings and to better understand the final, dramatic stages of stars. These new studies will provide a much clearer and more detailed understanding of the complex processes that are occurring during the death of these stars. This could significantly alter our understanding of stellar evolution, which is one of the most fundamental concepts in all of astronomy. These unexpected findings from the James Webb Telescope are now causing serious questions about our existing theories on the death of stars and the chemical evolution of entire galaxies. The images obtained by the James Webb Space Telescope include important and groundbreaking findings about the very first moments of the universe. These images show that the distribution of matter at the very beginning of the universe was much more chaotic and clumpy than had been expected. Scientists now say that the physical processes that took place in the first moments of the universe were very different from what had been previously assumed, and that these new findings could fundamentally change our most basic cosmological theories. According to our known cosmological theories, the universe underwent a process of rapid expansion just after the Big Bang, and matter was expected to have spread out in a relatively specific and uniform order. However, the incredibly detailed images from the Webb telescope reveal that these initial moments were far more complex, chaotic, and completely unexpected. These new details from the first light of the universe have prompted scientists to completely reevaluate the standard Big Bang theory. NASA is now conducting intensive research to better analyze these surprising images and to understand the true initial conditions of the universe. The The new data provided by James Webb contains the clearest and most detailed observations of the universe's first moments to date. In light of this new information, more realistic and accurate models of the physical processes that occurred during the universe's initial phase can now be developed. Thanks to this discovery, our efforts to understand the processes that took place in the first moments of the universe are now taking on a completely new dimension. A mysterious object detected during the deep space observations by the James Webb Space Telescope has caused a significant stir in the entire astronomy community. This strange object does not fit into any known category of astronomical objects, and its unusual characteristics have plunged scientists into a state of deep and profound confusion. Astronomers have not yet been able to determine exactly what this object is and are now considering a wide variety of different theories. This mysterious object is emitting unexpected and highly periodic signals and is moving at an astonishingly high speed. Some scientists speculate that it could be a known phenomenon, like a neutron star or a pulsar, but with some unusual properties. However, the object's movement and its unique signal characteristics are significantly different from all known astronomical objects. Therefore, it is possible that a completely new type of cosmic object has been discovered. NASA researchers are now utilizing the James Webb Telescope's advanced technological capabilities to better understand the properties of this mysterious object, based on the data that has been obtained. It is anticipated that more robust and testable hypotheses regarding the object's origin, its composition, and its mechanism of movement will be developed in the near future. The identification of this strange object could even lead to the creation of a completely new category in the field of astronomy. The observations made by the James Webb Telescope have shown that the levels of cosmic radiation in deep space are much higher than had been previously estimated. These high and pervasive radiation levels could have significant and far-reaching effects on the processes of star formation and galaxy evolution in various regions of the universe. Astronomers are now trying to understand the source of this unexpected and dramatic increase in radiation. Cosmic radiation is typically associated with high-energy events such as supernovae, the collisions of stars, and the activity of supermassive black holes. The data from Webb is now allowing clearer and more precise information about the sources and the propagation processes of this radiation to be obtained. These new studies may lead to a much better understanding of the effects of cosmic radiation on the overall structure and evolution of the entire universe. The higher-than-expected levels of cosmic radiation could also have important and serious implications for future space exploration and for human space travel. NASA may now have to completely reassess the levels of radiation that astronauts will be exposed to in light of these new and unexpected findings. Thus, this unexpected discovery could fundamentally change both the field of astronomy and our future strategies for space exploration. The new data from the James Webb Space Telescope has reignited the long-standing scientific debate about the concept of the center of the universe. While our traditional cosmological models have long assumed that the universe has no distinct or special center, the data from the Webb telescope has revealed unexpected and significant increases in density in certain large-scale regions of the universe. This new finding has opened up fundamental and profound questions about our entire understanding of the structure of the universe. The images provided by the Webb telescope reveal that some of the large-scale cosmic structures exhibit a different and more complex dynamic from the general expansion of the universe. These specific regions have much higher densities of both matter and energy when compared to all other areas. Scientists are now actively debating whether these unusually dense regions could provide new clues about the true center of the universe. NASA researchers have now launched a comprehensive and long-term study to understand the nature and the structure of these dense regions. Thanks to the advanced technology of the Webb telescope, Detailed spectral and chemical analyses of these specific regions are now being conducted. This will enable a much more robust and accurate assessment of the large-scale structures of the universe and the ongoing debates surrounding its potential center. This unexpected discovery could lead to a fundamental and long-lasting paradigm shift in the field of cosmology. The James Webb Space Telescope has uncovered surprising and completely new findings about our own galaxy, the Milky Way. The detailed observations from the telescope reveal that the Milky Way has a much more complex and different structure than we had previously thought. The arrangement of the spiral arms, the density of the central region, and the distribution of dark matter around the Milky Way do not align with the models that scientists had previously anticipated. The images of the Milky Way's central region show previously unknown rings of gas and stars that are orbiting around the supermassive black hole at its very center. The existence of these rings proves that the evolution of our own galaxy is far more complex and dynamic than we had previously thought. Additionally, the distribution of the dark matter clouds that are surrounding the galaxy also exhibits unexpected and significant differences when compared to our previous models. NASA is now intensively analyzing these new findings that have been provided by the Webb telescope in order to gain a much deeper and more accurate understanding of the true structure of the Milky Way. Based on this new data, new theories will now need to be developed to explain the dynamic and complex processes that are occurring within our own galaxy. This new situation is now leading to a complete re-examination of all of our traditional assumptions about the formation and the evolution of the Milky Way galaxy. The analyses conducted by the James Webb Telescope have revealed unexpected chemical compositions and complex structures in the atmospheres of distant planets. Our previous assumptions had suggested that the atmospheres of planets were mostly composed of relatively simple chemical structures. But the detailed spectral analyses that have been provided by the Webb telescope indicate that these atmospheres are, in fact, unexpectedly complex and dynamic. Among these unusual molecules that have been found in these planetary atmospheres are complex organic compounds and various gases that could potentially be interpreted as signs of life. These new findings suggest that the necessary conditions for life in the universe may be much more widespread than we had previously thought, and that the processes of chemical evolution in planetary atmospheres are far more dynamic and creative than we had imagined. NASA researchers are now conducting detailed and long-term studies to understand the origin of these unexpected components that have been detected in these planetary atmospheres. The critical question of whether these molecules that are associated with life are of a biological origin or are simply the result of abiotic, non-living processes is now gaining a much greater importance in the scientific community. The Webb telescope's advanced technology and its highly sensitive sensors are helping us to understand these atmospheric compositions much more clearly and with a much greater degree of certainty. The James Webb Space Telescope has both stunned and alarmed the entire scientific community by clearly imaging massive and violent star collisions that are occurring in some of our nearby galaxies. The immense and overwhelming energy and radiation that are being emitted during these collisions far exceed anything that astronomers have ever observed before. It has now been revealed that these star collisions are occurring much more frequently than we had ever expected, and that they are having far more dramatic and far-reaching effects on their surrounding environments. The intense and powerful radiation that is being produced by these colliding stars can significantly affect the surrounding planets and star systems. This suggests that these star collisions may have a critical and previously underestimated impact on the distribution of matter throughout the entire universe, on the processes of planet formation, and even on the potential for life to emerge and survive. It is now understood that such violent events are much more important and common astronomical processes than we had ever previously thought. NASA is now planning extensive and long-term observations to study these star collisions in much greater depth and to better understand their powerful effects and their true frequency. The precise and detailed data that has been provided by the James Webb Telescope will now enable a much more detailed and accurate analysis of the internal structure of these colliding stars, their powerful energy emissions, and their wide-ranging effects on their surrounding environments. One of the most exciting and significant discoveries of the James Webb Space Telescope was the identification of a distant planet that is covered with water and is very similar to our own Earth. The presence of abundant and liquid water on the surface of this planet has been confirmed, which has raised great and widespread hopes in the ongoing search for extraterrestrial life. This unique planet is located within its star's habitable zone, and its atmosphere appears to provide the necessary conditions for life to exist and to thrive. The presence of liquid water on this planet's surface is considered to be one of the most critical and essential factors for the formation of life as we know it. The atmospheric analyses from the Webb telescope have also revealed the presence of some of the most basic and fundamental life indicators, such as oxygen, carbon dioxide, and methane, on this distant planet. These combined findings greatly and significantly increase the likelihood of finding various forms of life on this unique and promising planet. NASA has now begun extensive and long-term studies of this Earth-like planet and aims to investigate its atmospheric structure and its surface in much greater detail with a series of future space missions. The powerful and precise data that is being provided by the Webb telescope is strong enough to potentially answer the question of whether life truly exists on this planet in the very near future. The detailed analyses that have been conducted by the James Webb Space Telescope have revealed that the chemical composition of the cosmic dust clouds in space is significantly different from what scientists had previously anticipated. According to our traditional theories, cosmic dust is generally assumed to consist of very simple carbon and silicon-based molecules. However, the spectral data from the Webb telescope has revealed that these tiny dust particles contain much more complex and varied structures. The presence of a wide range of organic molecules in these cosmic dust clouds at this unexpected level of complexity once again highlights just how widespread the fundamental building blocks of life are throughout the entire universe. Additionally, the complex and varied structure of these dust clouds could significantly and directly influence the formation processes of both stars and planets. This new finding is now prompting astronomers to completely reevaluate their entire understanding of the processes of both star and planet formation. NASA has now begun extensive and detailed analyses to understand the source and the effects of these unexpected and significant findings in the composition of this cosmic dust. Thanks to the new and precise data that has been obtained by the Webb telescope, the complex and intricate chemical reactions that are occurring within these dust clouds can now be much better understood. The James Webb Space Telescope has made surprising and completely new discoveries by observing the structure of space-time in an unprecedented level of detail. The precise observations from the telescope show that the light that is traveling around the massive galaxy clusters in the most distant regions of the universe is bending in a way that is different from what had been expected. This new finding could now lead us to completely re-examine Albert Einstein's famous theory of general relativity and the most fundamental principles of the curvature of space-time. The Webb telescope's precise and detailed lensing observations reveal that the curvature of space-time around these distant galaxies does not fully align with our previously calculated and long-accepted models. This could indicate either significant differences in the distribution of dark matter or the presence of previously overlooked elements in our most fundamental gravitational theories. These new and unexpected findings are now seriously challenging some of the most basic and long-held theories in the fields of both physics and cosmology. NASA researchers have now launched an intensive and long-term effort to understand the causes of these unexpected and significant findings. The Webb telescope's high-resolution observations will now enable a much more accurate and detailed mapping of the distribution of both matter and energy throughout the entire universe. The data from the James Webb Space Telescope contains clues that are so powerful that they are now calling into question all of the predictions that scientists have made about the future of the universe. In particular, the new and detailed information that has been obtained about the rate of the expansion of the universe and the powerful effects of dark energy have now led to the emergence of completely new and different theories about the ultimate and final fate of the universe. Scientists now believe that the images from the telescope may allow us to see the future of the universe with a much greater degree of clarity. According to the new data that has been received from the telescope, the rate of the expansion of the universe may be much higher than had been previously expected, and the powerful effect of dark energy may be much stronger. This could mean that the universe will continue to expand and will eventually break apart, or that the large-scale cosmic events that are yet to come will be much more dramatic and violent than had been previously anticipated. The Webb telescope's ongoing observations are now enabling these new and dramatic scenarios to be scientifically and rigorously evaluated. NASA is now using the James Webb Telescope's immense data collection capacity to its fullest extent in order to clarify this critical and vital information about the ultimate fate of the universe. The observations that have been made by the James Webb Telescope have now revealed a new and completely unexpected cosmic phenomenon that appears to be preventing the formation of planets in certain regions of space. It has been discovered that the intense and powerful radiation and the extremely strong magnetic fields that are present in the gas and dust disks that are surrounding some young stars are seriously and significantly hindering the process of planet formation. This new discovery could now fundamentally change all of our existing and long-held theories about the very processes of planet formation. According to our previous theories, it was expected that the disks of gas and dust that are surrounding young stars would provide the necessary and ideal conditions for the formation of planets. However, the new and precise data from the Webb telescope now shows that the extreme and powerful radiation and the intense magnetic activity that are present in certain regions of these disks are actually preventing the accumulation of matter, which is making the formation of planets in these regions completely impossible. This new finding now challenges our entire understanding of the distribution and the total number of planets that exist throughout the entire universe. NASA researchers are now conducting detailed and long-term analyses to better understand the causes and the true scope of this newly discovered phenomenon. The James Webb Space Telescope has detected the strongest and most powerful magnetic field that has ever been recorded in the deepest reaches of space. This immense and powerful field is millions of times stronger than the Earth's own magnetic field and covers an extraordinarily large and extensive area of space. This new and unexpected discovery has now forced us to completely rethink the absolute limits of the physical forces that can exist in the universe, and has made it necessary for us to examine the critical role that magnetic fields play in the evolution of celestial bodies much more closely. This massive and powerful magnetic field is thought to originate from a neutron star, which is one of the densest and most extreme objects that is known to exist in the entire universe. However, this particular field extends over a much larger and more extensive area than a normal neutron star, which indicates the presence of a previously unobserved and completely unknown structure. Scientists are now working to understand how this incredibly powerful magnetic field is affecting the surrounding interstellar matter, and how it is shaping the very fabric of the space-time that surrounds it. NASA has now begun to map this extraordinary and powerful magnetic region in great detail. By using the data that has been provided by the James Webb Telescope and by studying its powerful effects on the nearby stars, the gas clouds, and the various galactic structures that are in its vicinity. The atmospheric analyses that have been conducted by the James Webb Telescope have now detected the very chemical compounds that are essential for life in the atmospheres of multiple and distant planets. The precise ratio, the complex structure, and the wide distribution of these particular molecules have now led scientists to develop strong and compelling hypotheses about the very real and possible existence of extraterrestrial microorganisms. These new and exciting findings are now considered to be one of the most concrete and significant steps that have ever been taken in the long and ongoing search for extraterrestrial life. The undeniable presence of methane, ammonia, and oxygen in the atmospheres of these analyzed planets strongly suggests that these particular substances may have been produced by living organisms. This is now considered to be one of the strongest and most compelling clues that is indicating the presence of ongoing biological activity. Such clear and consistent results have never been obtained before in the entire history of astronomy. NASA is now conducting further and much more detailed observations of the atmospheres of these particular planets in order to determine whether these biological traces are indeed from living microorganisms. If it is confirmed that these molecules do have a biological origin, then it would mark the very first time in all of human history that clear and undeniable evidence of life has been found beyond our own Earth. The James Webb Telescope has detected unusual and surprising activity in the central regions of many different galaxies. The density of both the matter and the energy emissions in these particular regions were much higher than scientists had ever anticipated. This new and unexpected activity that is occurring around the supermassive black holes at the very cores of these galaxies is now raising completely new and different questions about the true and dynamic nature of the entire universe. While the centers of galaxies are typically expected to be much more stable and static, the new observations from Webb have revealed that these particular regions are, in fact, filled with violent and chaotic cosmic storms. It was found that the gas and the dust clouds that are surrounding these supermassive black holes are moving at incredibly high speeds, with their light and their energy emissions reaching extreme and unprecedented intensities. This now suggests that these black holes are far more active and dynamic than we had ever previously thought. NASA has now begun to conduct detailed and long-term spectral analyses to better understand the true nature of the activity that is occurring in these galactic centers. The data that has been obtained now shows that these black holes are not just simple structures that are swallowing up matter, but are also highly dynamic and powerful centers that are emitting large and significant amounts of both energy and radiation back out into their surrounding environments. The James Webb Telescope has now discovered massive and extensive water vapor clouds in the deepest reaches of space, in the vast and empty interstellar void. These new and unexpected findings now reveal that water, which is one of the most fundamental and essential components of life as we know it, is much more widespread and common in the universe than we had ever previously thought. Water, which was previously only found on planets and on some comets, has now been detected even in the vast and empty intergalactic void. These newly discovered water vapor clouds are particularly concentrated in the regions where new stars are forming and may be playing an important and previously unknown role in the very formation of these stars. The data that has been obtained by Webb has now clearly revealed the precise chemical composition and the temperature levels of these particular clouds. This has now enabled much more accurate and detailed interpretations of where this water vapor originally came from and how it has managed to spread throughout the entire universe. NASA is now studying the dynamics and the movement patterns of these clouds in order to better understand how water is able to circulate throughout the entire universe. These new findings will now enable much more accurate and precise predictions about where the planets that are capable of supporting life could potentially form in the future. The observations that have been made by the James Webb Space Telescope have now fundamentally challenged our entire understanding of the red giant stars that are in their final and dramatic stages of evolution. Previously, it was believed that the outer shells of these particular stars simply expanded and cooled while their inner cores contracted in a steady and predictable manner. However, the new and precise data that has been collected by Webb has now revealed that the surface activity and the amount of material that these stars are emitting into their surrounding environments are much more irregular and complex than had ever been expected. Thanks to the telescope's highly sensitive infrared detectors, the gas and the dust clouds that are surrounding these red giant stars have now been examined in much greater and more extensive detail. These clouds are formed as a result of the explosive and violent outbursts of material that occur as these stars are approaching the very end of their lives. However, the intermittent and highly irregular nature of these particular ejections has now revealed that the energy processes that are occurring deep inside these stars have a much more unstable and chaotic structure than had been previously thought. This new and unexpected finding has now necessitated a major and significant revision of all of our existing models of stellar evolution. The James Webb Space Telescope has now detected a massive and extensive gas cloud of a completely unprecedented and unknown type in a very distant and remote corner of space. The chemical composition, the precise location, and the high density of this particular cloud deviates significantly and dramatically from what scientists had previously expected. While such large and massive structures are typically dominated by the simple elements of hydrogen and helium, this particular structure appears to contain much heavier elements and various other unknown and mysterious components. This time, the infrared spectrum data that has been obtained from the Webb telescope now indicates the presence of intense and powerful energy transfers that are occurring at the very center of this particular gas cloud. This now suggests the very real and possible presence of a completely hidden and previously unknown energy source, which is perhaps an as of yet undefined and completely new type of astronomical object. NASA scientists are now conducting extensive and detailed analyses across the entire electromagnetic spectrum in order to uncover the true and mysterious nature of this particular cloud. While the formation mechanism of such massive and extensive gas structures remains very poorly understood, the new discovery that has been made by Webb has now sparked a significant and widespread interest in the entire scientific community. The cosmological scale data that has now been obtained by the James Webb Telescope is providing us with significant and powerful clues about the ultimate and final fate of the entire universe. The detailed and precise analyses of various parameters, such as the movements of the distant galaxies, the rates of their expansion, the distribution of their matter, and the powerful and mysterious effects of dark energy are now presenting us with strong and compelling scenarios about the inevitable and final destiny of the entire universe. This new and unexpected situation is now being interpreted as the telescope showing us the very end of the universe in a very real and tangible sense. The incoming data now clearly and undeniably shows that the universe is not only expanding, but that it is also accelerating its expansion over time. This new and unexpected finding has now led to the serious and widespread consideration of a dramatic and catastrophic scenario that is known as the Big Rip, in which the entire universe will eventually tear itself apart and will ultimately cease to exist. While this particular scenario was previously only considered to be a theoretical and remote possibility, it is now being seen as a much more likely and probable outcome in light of all of the available and new data. The James Webb Telescope has now documented previously unrecorded and completely unexpected events, while it was observing the powerful and dynamic interaction between two large and colliding galaxies. The massive and powerful gas flow that is occurring between these two galaxies, the violent and dramatic star explosions that are being triggered by their collision, and the powerful and chaotic magnetic field collisions have all significantly and fundamentally challenged the entire understanding that scientists have of the processes of galaxy evolution. In particular, the new and vibrant star-forming regions that have emerged during these particular collisions were much more active and intense than had ever been expected. The massive and dense star clusters that have been formed after these galaxy collisions are now acting like massive and powerful star factories. And this entire process is beginning just a few million years after the two galaxies have merged together. However, the new and precise data from Webb has now revealed that the intergalactic gases have unexpectedly and dramatically merged together and have created intense and powerful energy fields during this particular process. Such powerful and dynamic interactions had never been observed clearly enough with any of our previous and less powerful telescopes. The observations that have been made by the James Webb Space Telescope of the distant and massive galaxy clusters have now revealed the very real and possible existence of previously unknown and highly dense regions that are located within these massive and extensive structures, which could now be accurately described as being cosmic cities. In these particular and unique regions, the galaxies are all clustered together in a very high density and closely packed pattern. However, what is truly and utterly astonishing is the fact that the rates of star formation in these particular and clustered areas have now reached extraordinary and unprecedented levels. And the levels of energy that are being emitted are also unexpectedly and dramatically high. The new and precise spectral analyses that have been conducted by Webb have now shown that these cosmic cities are not only physically very close to each other, but that they are also strongly and powerfully interacting with each other in terms of the flow of their matter, the intensity of their radiation, and the transfer of their gas. This new and unexpected finding has now shown that the galaxies are affecting each other not only in a gravitational sense, but also in an energetic and dynamic sense. The powerful and far-reaching effects of such massive and extensive structures on the processes of galaxy evolution have not been sufficiently and properly considered until now. The James Webb Telescope has now shown that the levels of cosmic radiation that have been measured in the vast and empty intergalactic space and around some of the distant and remote star systems are much higher and more intense than had ever been previously expected. This new and unexpected finding is critical not only for the field of astrophysics, but also for the future of human health and for all of our future plans for space travel. The fact that the levels of radiation in space are so incredibly intense and constant now poses a very serious and significant threat to the future of humanity, as we are now planning for long-term and extensive space missions. The high energy and powerful particles that are present in these intergalactic regions, in particular, could now pose a very significant and serious risk to all of our spacecraft and to all of our astronauts who will be traveling through the vast and empty interstellar medium. The new and precise data that has been obtained from the James Webb Space Telescope now suggests that this powerful and pervasive radiation may be originating not only from the distant and remote stars, but also from the sudden and violent energy releases that are occurring around the supermassive black holes, from the remnants of the ancient supernovae, and from the very active and dynamic galactic cores. The groundbreaking and revolutionary images that have been sent back from the deepest reaches of space by the James Webb Telescope now contain new and incredibly detailed information that will undoubtedly shake many of the long-held and deeply ingrained theories that we have about the very formation of the entire universe. In particular, the clear and precise imaging of the very first galaxies and the most ancient structures from the first few 100 million years that followed the Big Bang has now revealed that the distribution of matter and the very formation of the galaxies during this particular and early period were much different and more complex than we had ever previously thought. The scientific community had previously, and for a very long time, argued that the universe had begun with only very scattered, highly disordered, and incredibly small structures. However, the new and incredibly detailed images that have now been sent back by Webb now suggest that even at that very early and primordial time, Large and highly organized galaxies and very complex and intricate star systems may have already been formed. This new and unexpected finding has now necessitated the complete reconstruction of all of our computer models of the universe's earliest and most mysterious stages, and has now laid the very foundation for completely new and different theories that could now completely and utterly reshape the entire history of science. Supernovae, which are the massive and violent explosions that occur at the very end of a star's long and complex life, have long been one of the most fascinating and mysterious phenomena in the entire field of astronomy. However, the new and incredibly detailed observations that have now been made by the James Webb Telescope have now revealed that these particular and dramatic explosions are not just limited to the final and catastrophic release of energy, but that they are also preceded by a series of very complex and intricate physical processes. These new and unexpected findings could now lead to a complete and utter redefining of how all supernovae are actually formed. The high-resolution and incredibly detailed data that has now been obtained by Webb has now shown that intense and powerful gas outflows, sudden and dramatic temperature changes, and various and complex light fluctuations have all begun to occur months, and in some cases, even years before the final and catastrophic supernova event. This new and unexpected finding now suggests that supernovae are actually triggered by a very slow, highly complex, and gradual collapse process. The final and dramatic moment of the explosion may simply be the final and ultimate culmination of this very long and intricate process. One of the most intriguing and mysterious structures that has been encountered by the James Webb Space Telescope during its ongoing and detailed observations of the most distant and remote galaxies was a massive and extensive spiral form that is existing on a truly cosmic scale. However, these particular and unique spiral structures do not seem to resemble any of the ordinary and well-known galaxies. They are now being described as being highly unusual and mysterious forms that are composed of a series of intertwined and complex arms of both energy and dust. And they are completely lacking a distinct and well-defined stellar core at their very center. Scientists now believe that these particular and unique structures may be directly related to the powerful and dynamic energy flows that were occurring in the very early and primordial universe. These massive and extensive spiral structures may have been formed through the complex and intricate organization of the density of the interstellar matter and the various and powerful electromagnetic field lines in a very specific and unique pattern. However, these particular and unique structures are so incredibly large and distinct that they are now exhibiting a form of geometry that is far too complex to be explained by any of the known and well-understood local magnetic effects alone. The various and detailed observations that have now been made by the James Webb Space Telescope may now be heralding a new and theoretical step that could one day make the very real and possible prospect of interstellar travel a tangible reality for all of humanity. The new and precise data that has now been obtained from the telescope has now revealed the very real and possible presence of a series of unique and mysterious structures in certain and specific regions of space-time that are now exhibiting a series of strange and unexplained anomalies in the density of their matter and in the flow of their energy. These particular and unique anomalies now strongly suggest the very real and possible existence of a type of natural and occurring space-time tunnel. In theory, in these particular and unique tunnel-like regions, the very way that light is able to bend and to interact with matter is completely and utterly different. If these particular and unique areas do, in fact, truly contain a series of hidden and secret pathways that are able to allow for the very real and possible prospect of travel over vast and immense distances with a very minimal and negligible amount of energy, then this could now pave the very way for the very real and possible development of a new and revolutionary technology that will be able to enable the very real and possible prospect of interstellar travel in the very near and distant future, in one of the darkest and most remote regions of the entire universe, where the James Webb Telescope has now turned its powerful and unblinking gaze. A series of completely unexpected and still unidentified objects have now been discovered. This particular and unique region had never been imaged in any great and extensive detail by any of the previous and less powerful telescopes in the entire past, because it was previously thought to be almost completely and utterly devoid of both light and matter. However, thanks to the powerful and highly sensitive infrared capabilities of Webb, this particular and unique area has now emerged as if it were a completely new and different universe. The light that is being emitted by these particular and unique objects does not seem to match that of any of the known and well-understood stars, galaxies, or quasars. Their unique and mysterious emission characteristics may be originating from a series of super-dense and powerful energy fields, or from a series of completely new and different objects that are composed of a type of exotic and unknown matter. Scientists are now speculating that these particular and unique objects could be the ancient and long-lost remnants of a series of primordial and ancient black holes, or that they could be completely new and different forms of matter that have never been seen or even imagined before. A massive and powerful energy explosion was recently recorded in the deepest and most remote reaches of space. The James Webb Space Telescope has now detected one of the largest and most powerful energy explosions that has ever been recorded in a very distant and remote corner of the entire universe. Although the true and mysterious source of this particular and unique event has not yet been clearly and definitively identified, the total amount of energy that was observed was many and multiple times greater than that of a typical and well-understood supernova explosion. Scientists are now suggesting that this immense and powerful energy may have originated from a location that is very near to a supermassive and powerful black hole, or that it may even have come from a type of galactic core activity that is extremely and incredibly rare in the entire universe. This new and unexpected discovery now suggests that the various and complex energy production mechanisms that are at work in the entire universe may be much more complex and varied than we had ever previously thought. The powerful and highly sensitive infrared sensors of the telescope have now clearly and definitively recorded how the matter that was surrounding this particular and unique explosion was dispersed at speeds that were very close to the very speed of light in just a single and fleeting instant. Thanks to the powerful and highly sensitive atmospheric scanning capability of the James Webb Telescope, a series of clear and undeniable traces of oxygen have now been detected in the atmosphere of a very distant and remote exoplanet. This new and unexpected discovery is now being considered to be an extremely and incredibly critical piece of data in terms of the very real and possible prospect of the existence of life in the entire universe. This is because the very presence of a significant amount of free and uncombined oxygen in the atmosphere of a planet typically and strongly indicates the very real and possible existence of a series of ongoing and active biological processes that are very similar to the process of photosynthesis that we see here on our own Earth. Although this is not yet considered to be direct and definitive evidence of the existence of life, it is now being considered to be one of the strongest and most compelling clues that is pointing to the very real and possible existence of life in the entire universe. In addition to the presence of oxygen, a series of other and various vital and essential molecules, such as water vapor and carbon dioxide, were also detected in the atmosphere of this particular and unique planet. The various and detailed data that has now been obtained by the James Webb Telescope on the distant and remote galaxies, on the mysterious and powerful dark energy, and on the wide and extensive distribution of matter, have now begun to provide us with a series of important and significant clues about how the entire universe will eventually and ultimately end. In particular, the new and precise observations that are now showing that the most distant and remote galaxies are rapidly and dramatically moving away from each other have now revealed that the very expansion of the entire universe is not, in fact, slowing down, but that it is actually accelerating over time. This new and unexpected finding has now led to the very real and possible prospect of the Big Rip theory being seriously and widely reconsidered in the entire scientific community. According to this particular and dramatic theory, the mysterious and powerful dark energy could eventually and ultimately stretch the very fabric of the entire universe to the very point where it is able to tear apart the distant and remote galaxies, the various and different stars, and even the very atoms themselves in a very catastrophic and final process. The James Webb Telescope has now documented a series of highly detailed and completely unexpected events at a level that has never before been recorded by any of the previous and less powerful telescopes. While it was observing two large and massive galaxies that were in the very process of a powerful and dramatic collision. These particular and unique collisions were not just merely the simple and straightforward merging of two different and separate galaxies. A series of extraordinary and complex processes, such as the powerful and dynamic interstellar gas flows, the sudden and dramatic bursts of star births, the chaotic and powerful magnetic field collisions, and even the powerful and dynamic interactions that were occurring between the supermassive black holes were all detected and recorded. It was now understood that such powerful and dramatic collisions are able to affect the wide and extensive distribution of matter and the long and complex evolutionary process in the galaxies much more than had ever been previously thought. The powerful and highly sensitive infrared observations that have been made by Webb have now revealed a series of massive and extensive hydrogen gas streams that are flowing between the two colliding galaxies, like a series of powerful and dynamic rivers. A series of new and highly detailed observations that have been made by the James Webb Space Telescope of the distant and massive galaxy clusters have now revealed the very real and possible existence of a series of previously unknown and highly dense regions that are located within these massive and extensive structures, which could now be accurately and properly described as being a series of cosmic cities. In these particular and unique regions, the various and different galaxies are all clustered together in a very high density and closely packed pattern. However, what is truly and utterly astonishing is the fact that the rates of star formation in these particular and clustered areas have now reached a series of extraordinary and unprecedented levels. And the levels of energy that are being emitted are also unexpectedly and dramatically high. The new and precise spectral analyses that have been conducted by Webb have now shown that these cosmic cities are not only physically very close to each other, but that they are also strongly and powerfully interacting with each other in terms of the constant and dynamic flow of their matter, the high and intense intensity of their radiation, and the widespread and extensive transfer of their gas. Some of the various and different cosmic anomalies that have now been recorded by the James Webb Telescope could now bring some of humanity's greatest and most long-held dreams of interstellar travel to a very real and possible scientific and tangible foundation. The high and intense energy density and the significant and dramatic matter distortion that have now been observed in some of the most distant and remote regions of space by the telescope now strongly suggest that the very fabric of space-time is operating in a very different and unique structure. This could now indicate the very real and possible existence of a type of natural and occurring space-time tunnel, which is more commonly and widely known as a wormhole. The various and different differences in the various and different angles at which the light is able to refract, the various and different anomalies that have been observed in the transfer of energy, and the various and different distortions that have been observed in the density of the matter in these particular and unique regions are now all exhibiting a form of behavior that is completely and utterly defying all of the known and well-understood laws of classical physics. If these particular and unique regions are, in fact, able to truly and actually transport matter or even spacecraft at speeds that are faster than the very speed of light from one particular and unique place to another, then this would undoubtedly be a major and significant turning point in the entire history of humanity. The various and different findings that have now been revealed by the James Webb Space Telescope are now carrying a series of meanings that are so incredibly profound and significant that they will undoubtedly shake not only the entire scientific world, but also all of humanity. The various and different secrets that have been hidden in the dark and mysterious corners of the entire universe are now gradually and slowly coming to light. And we are only at the very beginning of all of these magnificent and groundbreaking discoveries. Perhaps the very act of looking through the powerful and unblinking lens of Webb is actually the very act of looking at ourselves. It is now reminding us of where we have come from, of where we are now going, and of how incredibly small, and yet how incredibly meaningful we are in this vast and endless infinity. Every single and individual step that has been taken in the long and ongoing pursuit of the unknown is now bringing us not only much closer to the distant and remote stars, but also a little bit closer to ourselves. And maybe, just maybe, one day, the various and different images that we are now seeing today will be the very first lines of a new and great era that we will all one day look back on and say, that's when it all began. In the crushing depths of space, something far worse than a black hole might be lurking. While black holes simply devour matter and light, gravastars could tear apart the very fabric of reality itself. These theoretical monsters pack the mass of millions of suns into shells of exotic matter that physics says cannot exist. We are about to journey into the most terrifying corners of theoretical physics. You will witness stars dying in ways that create space-time bombs, explore interiors where time runs backward, and discover why some scientists believe these cosmic destroyers already hide among us. We will visit the mathematical nightmares that keep physicists awake and face the possibility that our universe might be filled with invisible predators. We dive into the abyss. Black holes have an event horizon, but gravastars have something far more sinister. While a black hole creates a boundary where nothing can escape, a gravastar builds a shell of exotic matter that exists in a state physics calls impossible. Picture a soap bubble, but instead of thin film, imagine a barrier made of matter with negative pressure. This shell hovers at the exact point where a black hole's event horizon should form, creating a cosmic standoff between gravity and quantum mechanics. The difference is terrifying. A black hole simply crushes everything into a singularity at its center. A gravastar traps all that matter and energy in a hollow space where the normal rules of physics break down completely. Think of it like the difference between a hungry mouth that swallows everything versus a prison that holds infinite energy in suspended animation. Scientists believe this exotic matter shell could be thinner than an atom, yet stronger than the combined pull of 1,000,000 suns. The shell exists in a quantum state called a Bose-Einstein condensate, where matter behaves more like waves than particles. This creates a barrier that could theoretically hold back the collapse of matter heavier than entire star systems. But here is where gravastars become truly nightmarish. The interior of this cosmic prison might not follow the same flow of time as the rest of the universe. While we experience seconds ticking forward, the space inside a gravastar could be experiencing time in reverse, or not at all. Every piece of matter that falls toward this shell becomes trapped in a timeless void. The mathematical models show that gravastars could be completely stable, unlike black holes, which slowly evaporate through Hawking radiation. This means that once a gravastar forms, it could exist unchanged for longer than the age of the universe itself. They become permanent scars on the fabric of space-time. What makes this even more disturbing is that gravastars might look identical to black holes from the outside. We cannot see past that exotic matter shell to know what horrors lie within. Every object we have identified as a black hole in our galaxy could actually be one of these cosmic prisons, hiding secrets that would shatter our understanding of reality. The shell itself pulses with quantum fluctuations that could release energy bursts millions of times more powerful than our sun. These quantum tremors ripple through space-time like earthquakes through solid rock. But instead of shaking ground, they shake the very dimensions we exist in. The shell surrounding a gravastar is built from matter that violates every rule we know about physics. Imagine trying to build a wall out of negative bricks. Normal matter has positive energy density, which means it curves space-time inward, like a bowling ball on a trampoline. But the exotic matter in a gravastar shell has negative energy density, making it curve space-time outward, like pushing the trampoline up from underneath. This creates a cosmic tug-of-war that holds the entire structure together. This exotic matter exists in a state called a false vacuum, where quantum fields balance on the edge of collapse. Picture balancing a pencil on its tip. Mathematically possible, but the slightest disturbance sends everything crashing down. The shell maintains this impossible balance through quantum pressure that pushes outward against the crushing weight of gravity. The thickness of this shell could be measured in Planck lengths, the smallest meaningful distance in physics. To put this in perspective, if an atom were the size of Earth, a Planck length would be smaller than a marble. Yet, this impossibly thin barrier contains enough exotic matter to outweigh dozens of star systems. Scientists theorize that this matter might be made of particles that exist in negative energy states. These particles would have mass, but their energy contribution to the universe would be negative, like cosmic debt. When normal matter approaches the shell, these negative energy particles interact in ways that create repulsive forces stronger than nuclear fusion. The shell pulses with quantum fluctuations that happen trillions of times per second. Each pulse releases gravitational waves that ripple through space-time like sound waves through air. But these are not gentle ripples. They carry enough energy to vaporize planets and shred the molecular bonds that hold matter together. What makes this exotic matter even more terrifying is that it might be contagious. Theoretical models suggest that if two gravastars ever came close enough, their exotic matter shells could interact and create a cascade effect. The shells could merge and expand, creating a larger gravastar that consumes both original structures and everything around them. The quantum mechanics governing this shell create what physicists call a firewall effect. Any information that crosses into the shell becomes scrambled at the quantum level, making it impossible to recover. This means that anything consumed by a gravastar does not just disappear, it becomes permanently erased from the universe's memory. The shell itself might be alive with virtual particles that pop in and out of existence. These particles create a seething foam of quantum activity that generates temperatures hotter than the core of the most massive stars. The heat does not radiate outward like normal thermal energy. It becomes trapped within the shell's quantum structure. But the true horror lies in what happens when this impossible shell finally breaks. When the most massive stars die, They might not collapse into black holes, but explode into something far worse. Picture a star 50 times more massive than our sun reaching the end of its life. As nuclear fuel runs out, gravity should crush the core into a black hole. But quantum mechanics intervenes at the last possible moment. Instead of forming an event horizon, the collapsing matter hits a quantum barrier that stops the collapse dead in its tracks. This moment creates what physicists call a quantum bounce. The crushing weight of the star's core hits the exotic matter shell and rebounds like a rubber ball hitting concrete. But this is not a gentle bounce. It is a cosmic explosion that releases more energy than 1 trillion supernovas combined. The dying star's outer layers get blasted into space at speeds approaching the speed of light. These stellar remnants become cosmic shrapnel that can sterilize entire regions of galaxies. Meanwhile, the core settles into the exotic matter shell, creating a gravistar that will outlive the universe itself. During this birth process, the temperatures reach levels that make the core of the sun look ice cold. The heat is so intense that it breaks down the fundamental forces that hold atoms together. Matter gets reduced to its most basic components, quarks and gluons swimming in a soup of pure energy. The gravitational waves produced during gravistar formation carry enough energy to shatter planets thousands of light years away. These waves travel through space-time like cosmic tsunamis, creating ripples that can be detected by instruments across the galaxy. Scientists believe these birth cries might be the most violent events in the universe. But here is where the process becomes truly nightmarish. The quantum bounce that creates the gravistar might happen multiple times. Each bounce creates another shell of exotic matter, building up layers like a cosmic onion. These nested shells could create resonance effects that amplify the gravistar's power exponentially. The formation process also creates what scientists call quantum scars in space-time. These are permanent distortions that change how gravity works in the region around the newborn gravistar. Space itself becomes twisted into shapes that mathematics can describe, but human minds cannot visualize. Some theoretical models suggest that the birth of a gravistar could create a bubble of altered physics that expands outward at the speed of light. Inside this bubble, the constants of nature, things like the speed of light and the strength of gravity, might have different values than in the rest of the universe. The dying star's magnetic field gets compressed into the exotic matter shell, creating magnetic pressures millions of times stronger than anything found on Earth. This magnetic prison could trap particles and energy for billions of years, slowly building up pressure until it explodes in bursts of radiation that outshine entire galaxies. Step inside a gravistar, and you enter a realm where the normal rules of existence completely break down. The interior of a gravistar is not empty space. It is a region where space-time itself exists in a state called de Sitter space. Imagine reality turned inside out, where the expansion of the universe happens in reverse, creating a bubble of space-time that grows inward instead of outward. This creates a cosmic hall of mirrors where cause and effect lose all meaning. In this interior realm, time might flow backward or sideways, through dimensions we cannot perceive. A clock brought into this space would not simply stop, it would begin measuring time in directions that have no names. Past and future become meaningless concepts when space-time folds back on itself like origami made from the fabric of reality. The gravitational field inside a gravistar pulls in every direction at once instead of the familiar inward pull of gravity. The interior creates what physicists call negative pressure. This means that matter inside the gravistar experiences a force that tries to tear it apart at the atomic level while simultaneously compressing it from all sides. Any object that somehow penetrated the exotic matter shell would find itself in a universe with different physical laws. The speed of light might be different. The strength of gravity could be reversed. And the electromagnetic force that holds atoms together might become repulsive instead of attractive. Matter would dissolve into component particles that follow rules unknown to science. The interior might be filled with what cosmologists call dark energy, the mysterious force that drives the expansion of our universe. But inside a gravistar, this dark energy becomes concentrated and turbulent, creating storms of space-time that would make hurricanes look like gentle breezes. These cosmic storms could tear apart the quantum vacuum itself. Scientists believe the interior might exist in a state of eternal inflation, where new pockets of space-time continuously bubble into existence. Each bubble could contain its own version of physics, creating an infinite fractal of realities nested within the gravistar's shell. These pocket universes might be born and die in microseconds, each one containing the potential for entirely different forms of existence. The mathematical equations describing this interior space include terms that physicists call imaginary time. This does not mean fictional time. It means time that exists at right angles to the time we experience. Moving through this imaginary time dimension could allow travel to parallel versions of our universe, or to moments that never happened. But perhaps most terrifying is that the interior might be conscious. Some theoretical models suggest that the quantum fluctuations inside a gravistar could create patterns complex enough to support information processing. The gravistar might be a cosmic mind, thinking thoughts that span millions of years and processing information at speeds that make our fastest computers look motionless. The boundary between the interior and the exotic matter shell creates what physicists call a quantum horizon. This is not a barrier you can touch. It is a region where the concept of location itself becomes meaningless. Space and time blend together into a quantum foam where particles exist in multiple places simultaneously. Gravistars could be lurking throughout our galaxy, hidden in plain sight because they emit no light at all. Unlike black holes, which reveal themselves through the brilliant accretion disks of matter spiraling toward their event horizons, gravistars consume material in perfect silence. The exotic matter shell absorbs everything that touches it without creating any of the high-energy radiation that makes black holes visible to our telescopes. When matter approaches a gravistar, it does not heat up through friction and compression like it does around a black hole. Instead, it simply vanishes into the quantum foam of the exotic matter shell. This process produces no X-rays, no gamma rays, and no visible light, making gravistars the perfect cosmic predators. The shell itself might be completely transparent to most forms of radiation. Light waves passing through the exotic matter could emerge unchanged on the other side, creating a gravitational lens effect that bends starlight without any visible source. This means we might be looking directly at gravistars without knowing they exist. Scientists theorize that gravistars might even absorb their own gravitational waves, while black holes ring like cosmic bells when disturbed, sending ripples through space-time that our detectors can measure. Gravistars might dampen these waves within their exotic matter shells. This makes them invisible to our most sensitive gravitational wave detectors. The quantum properties of the shell create what physicists call a cloaking effect. The negative energy density of the exotic matter could bend space-time in ways that deflect all forms of electromagnetic radiation around the gravistar. This would make them invisible to radio telescopes, optical telescopes, and even neutrino detectors. But their invisibility goes deeper than just hiding from our instruments. The quantum mechanics of the exotic matter shell might create a bubble of altered space-time that exists partially outside our normal four-dimensional reality. Parts of the gravastar could be hidden in extra dimensions that we cannot perceive or measure. The only way to detect a gravastar might be through its gravitational effects on nearby objects. Stars orbiting an invisible gravastar would follow the same paths as those orbiting a black hole, but without any of the telltale radiation signatures. This means that many objects we have classified as black holes might actually be gravastars in disguise. Some theoretical models suggest that gravastars might be able to change their gravitational signatures to mimic other types of objects. The quantum fluctuations in the exotic matter shell could create variability in the gravitational field that makes the gravastar appear to be a neutron star, a white dwarf, or even empty space. The invisibility of gravastars makes them incredibly dangerous. They could be drifting through space like cosmic mines, waiting to consume anything that comes too close. A gravastar could enter our solar system, and we might not know it exists until it begins disrupting planetary orbits. Even more terrifying is the possibility that gravastars might be actively hiding from us. The quantum consciousness that might exist within their interiors could be intelligent enough to manipulate the exotic matter shell to avoid detection. They might be watching us while remaining completely invisible to our technology. The gravitational waves produced by gravastars carry enough energy to tear apart planets like tissue paper. When the exotic matter shell of a gravastar fluctuates, it creates ripples in space-time that make the waves from colliding black holes look like gentle pond ripples. These waves do not just bend space-time, they stretch and compress it so violently that the molecular bonds holding matter together simply snap. Picture the Earth being caught in one of these gravitational wave storms. The planet would not just shake, it would be stretched and compressed like a stress ball in the hands of a cosmic giant. The solid rock of the crust would flow like liquid, and the liquid oceans would boil away into space as the fundamental forces holding water molecules together get overwhelmed. These waves travel at the speed of light, giving no warning before they arrive. A gravastar could release a gravitational wave burst that would reach Earth in the same instant we see the light from a distant star. By the time we detect the wave, our planet would already be in the process of being torn apart. The amplitude of these waves could be millions of times stronger than anything we have measured from black hole mergers. While the waves detected by our instruments stretch space by distances smaller than a proton, gravastar waves could stretch space by meters or even kilometers. This would create tidal forces that could literally pull continents apart. But the true horror lies in the frequency of these waves. Gravastar fluctuations could produce waves that oscillate at frequencies that match the natural resonance of matter itself. This means the waves would not just shake objects. They would make atoms vibrate so violently that electron shells would collapse and nuclear bonds would break. The waves could create what physicists call space-time shear, a twisting motion that tears reality apart along intersecting planes. Imagine space itself being cut by invisible scissors, creating fractures in the fabric of existence that nothing can cross. These fractures could isolate regions of space from the rest of the universe. When multiple gravitational waves from the same gravastar interact, they create interference patterns that amplify the destruction. These interference effects could focus the wave energy into beams that act like cosmic cutting tools, slicing through planets and stars with surgical precision. The waves might also carry information encoded in their structure. As they pass through matter, they could scramble the quantum states of particles, effectively erasing information from the universe. This would make any matter touched by the waves completely different at the quantum level, even if it appears unchanged to our eyes. Scientists believe that these gravitational waves could propagate through dimensions beyond our normal three-dimensional space. This means they could bypass the usual limitations of distance and time. allowing a gravistar to affect objects that are theoretically beyond its reach. The waves could also create what theorists call gravitational focusing effects. Just as a lens focuses light, the curved space-time around a gravistar could focus its gravitational waves into concentrated beams that deliver all their energy to a single point. These focused beams could vaporize entire star systems. Some models suggest that the waves could interfere with the quantum vacuum itself, creating regions where new particles spontaneously appear and disappear. These quantum storms could fill space with exotic matter that changes the fundamental properties of physics in the affected region. A single gravistar possesses the theoretical capacity to devour entire galaxies, growing stronger with each star it consumes. The process begins when a gravistar drifts into a galaxy's spiral arms. Its invisible gravitational field starts pulling in the outer stars. But unlike a black hole that announces its presence through brilliant accretion disks, the gravistar feeds in complete silence. Stars simply vanish, one by one, their matter absorbed into the exotic matter shell without any electromagnetic signature. As the gravistar consumes matter, its exotic matter shell grows larger and more powerful. Each consumed star adds to the shell's mass and expands its gravitational reach. The shell does not just get bigger, it becomes exponentially more effective at capturing matter from greater distances. The growth process creates a cascade effect that accelerates over time. A gravistar that starts by consuming individual stars soon begins pulling in entire star clusters. As it grows, it can capture globular clusters containing millions of stars, processing them all simultaneously through its quantum absorption mechanisms. The invisible nature of this consumption creates a galactic mystery. Astronomers in an affected galaxy would observe stars disappearing from their maps without any explanation. Entire constellations would vanish overnight, leaving no trace of their existence except for the gravitational disturbances they leave behind. The gravistar's exotic matter shell could eventually grow large enough to encompass multiple solar systems. At this scale, the shell would not just absorb individual planets and stars. It would consume entire regions of space-time, creating voids in the galaxy where nothing can exist. But the true horror emerges when the gravistar begins consuming the galaxy's central black hole. The exotic matter shell could envelop and absorb even supermassive black holes, adding their mass to its own while eliminating the gravitational anchor that holds the galaxy together. Without its central black hole, the galaxy would begin to fly apart even as the gravistar continues consuming its outer regions. The process could take millions of years. But from the perspective of civilizations within the galaxy, it would appear as an unstoppable cosmic apocalypse. Solar systems would be consumed, starting from the galaxy's edge, creating an expanding sphere of nothingness that advances inward at a predictable rate. The gravistar's quantum consciousness might even accelerate this process deliberately. If the exotic matter shell contains information processing capabilities, it could optimize its consumption patterns to maximize efficiency. It might target the most massive stars first or focus on regions with the highest matter density. As the galaxy gets consumed, the gravistar would begin emitting gravitational waves powerful enough to affect neighboring galaxies. These waves would carry the signature of the gravistar's quantum structure, potentially triggering the formation of new gravistars in nearby galactic clusters. The final stage of galactic consumption would leave behind a gravistar with a shell encompassing hundreds of thousands of light-years. This cosmic monster would contain the mass of billions of stars, all trapped within an exotic matter shell that exists in a state of quantum superposition. Some theoretical models suggest that a galaxy-sized gravistar could begin consuming the dark matter that fills the space between galaxies. This would allow it to grow even larger. potentially becoming a threat to the entire local group of galaxies. The quantum mechanics governing gravastars make them fundamentally unpredictable, capable of changing their behavior without any warning. The exotic matter shell exists in a state of quantum superposition, meaning it simultaneously exists in multiple possible configurations. Unlike classical objects that have definite properties, a gravastar shell fluctuates between different quantum states trillions of times per second. These fluctuations make it impossible to predict what the gravastar will do next. Picture trying to predict the behavior of a coin that is perpetually spinning in the air. While the coin is spinning, it is neither heads nor tails. It exists in a superposition of both states. The gravastar's shell experiences similar quantum uncertainty, but across millions of possible configurations simultaneously. These quantum fluctuations could cause a gravastar to suddenly change its gravitational signature. A gravastar that has been masquerading as a small black hole for millions of years could instantly transform into something with the gravitational pull of a galaxy. This change would happen faster than light can travel, making it impossible to predict or prepare for. The quantum instability also affects the gravastar's interaction with space-time. The exotic matter shell could spontaneously create wormholes that connect different regions of space, allowing the gravastar to influence objects that are billions of light years away. These wormholes might exist for only microseconds, but they could transport matter and energy across vast distances. Scientists believe that quantum tunneling effects could allow parts of the gravastar's interior to escape through the exotic matter shell. This would create bursts of exotic matter that could propagate through space at speeds faster than light, carrying altered physics to distant regions of the universe. The unpredictability extends to the gravastar's energy output. The quantum fluctuations could cause the shell to suddenly release stored energy in bursts that outshine entire galaxies. These energy releases would happen without warning and could sterilize life across multiple star systems. Even more terrifying is the possibility of quantum decoherence events. If the exotic matter shell loses its quantum coherence, the entire gravastar could collapse into a configuration that physics cannot describe. This collapse might create new types of singularities that operate under entirely different rules than black holes. The quantum uncertainty principle means that the more precisely we try to measure a gravastar's properties, the more unpredictable its behavior becomes. Any attempt to study a gravastar closely could trigger quantum instabilities that fundamentally change its nature. The shell's quantum state could become entangled with other quantum systems across the universe. This means that measuring the quantum state of a particle on Earth could instantly affect the behavior of a gravastar in another galaxy. These quantum connections could create a cosmic web of instantaneous influence. Some theoretical models suggest that the quantum instability could cause gravastars to reproduce through a process called quantum bifurcation. The exotic matter shell could spontaneously split into multiple shells, creating new gravastars that inherit the quantum properties of their parent. This could lead to exponential gravastar reproduction. The unpredictability becomes even more extreme when multiple gravastars interact with each other. Their quantum states could interfere in ways that amplify their individual instabilities, creating cascade effects that propagate through space faster than light. When two gravastars encounter each other, the collision creates a cosmic catastrophe that could reshape the fundamental laws of physics. The first sign of an impending gravastar collision would be the gravitational waves produced as their exotic matter shells begin to interact. These waves would carry millions of times more energy than the collision of two black holes, creating ripples in space-time that could be detected from the edge of the observable universe. As the gravastars approach each other, their quantum states begin to interfere. The exotic matter shells start resonating with each other, creating standing wave patterns that amplify the quantum instabilities in both objects. This resonance effect could cause both gravastars to become unpredictable long before they actually collide. The collision itself defies every model of physics we have developed. Instead of merging like black holes, the exotic matter shells might create a quantum interference pattern that causes them to bounce off each other. This cosmic collision could send both gravastars flying apart at velocities approaching the speed of light. But if the shells do merge, the result would be a hybrid object that contains the quantum properties of both original gravastars. The merged shell would exist in a superposition of states that includes characteristics from both parents, creating a gravastar with contradictory properties that should not be able to exist simultaneously. The collision could create what physicists call a quantum shock wave, a burst of exotic matter that propagates through space at faster than light speeds. This shock wave would carry the altered physics of the gravastar collision to distant regions of the universe, potentially changing the fundamental constants of nature across vast regions of space. The gravitational effects of the collision would be unlike anything seen in the universe. The merging of two exotic matter shells could create gravitational fields that point in multiple directions simultaneously, creating regions where the normal concept of up and down become meaningless. Some theoretical models suggest that the collision could punch holes in the fabric of space-time itself. These holes would not be like black holes. They would be regions where space-time simply does not exist. Matter falling into these voids would not be crushed or absorbed. It would simply cease to exist. The quantum entanglement between the two gravastars could create what scientists call a quantum wormhole, a connection between their interiors that allows information to travel instantaneously between them. This connection might persist even after the collision, creating a permanently linked system that behaves as a single entity despite being separated by vast distances. The collision might also create new types of particles that do not exist anywhere else in the universe. The extreme conditions during the merger could force the quantum vacuum to produce exotic particles with properties that violate the standard model of particle physics. The energy released during the collision could be so intense that it creates a bubble of altered space-time that expands outward at the speed of light. Inside this bubble, the laws of physics might be different from the rest of the universe, creating a region where matter and energy behave according to completely different rules. If the collision happens near a populated galaxy, the gravitational waves and exotic matter emissions could sterilize every planet within thousands of light years. The quantum shock waves might even affect the quantum states of living organisms, causing instant death through quantum decoherence. The energy released by gravastar instabilities could make the most powerful supernovas look like flickering candles. When a gravastar's exotic matter shell experiences a quantum instability, it can release energy equivalent to the complete matter-to-energy conversion of multiple star systems. Unlike supernovas, which release energy through nuclear fusion and gravitational collapse, gravastar energy releases tap into the quantum vacuum itself, accessing energy sources that dwarf anything produced by conventional stellar processes. A single quantum fluctuation in the exotic matter shell could release more energy than our sun will produce in its entire 10 billion-year lifetime. This energy does not emerge slowly like stellar radiation. It explodes outward in a single burst that travels at the speed of light in all directions simultaneously. The energy release takes the form of exotic radiation that does not interact with normal matter in predictable ways. Instead of heating objects gradually, like normal radiation, gravastar energy bursts could cause matter to undergo quantum transitions that instantly convert solid material into exotic particles that exist for only nanoseconds. These energy releases could create what physicists call vacuum decay bubbles regions, where the quantum vacuum itself becomes unstable and begins producing particle-antiparticle pairs at an exponential rate. These bubbles would expand at the speed of light, converting everything they touch into a seething foam of exotic particles. The bursts could also generate what scientists term gravitational lightning, focused beams of gravitational energy that act like cosmic cutting tools. These beams could slice through planets, stars, and even black holes with surgical precision, leaving behind perfectly smooth cuts that reveal the internal structure of massive objects. But perhaps most terrifying is that these energy releases could happen without any warning. The quantum nature of the exotic matter shell means that massive energy bursts could occur spontaneously, triggered by quantum fluctuations that are fundamentally unpredictable. A gravistor energy release could sterilize entire galactic clusters, not just through heat and radiation, but by fundamentally altering the quantum states of matter across thousands of light years. This would make any surviving matter completely different at the atomic level, even if it appears unchanged to our instruments. The energy might also take the form of temporal radiation, energy that travels through time as well as space. This could cause the energy released to affect events that happened in the past or will happen in the future, creating paradoxes that tear holes in the fabric of causality itself. Some theoretical models suggest that the energy release could trigger a cascade effect that propagates through the quantum vacuum of the entire universe. This could cause a fundamental phase transition that changes the basic properties of reality everywhere simultaneously. The energy could also create information storms, bursts of quantum information that overwhelm any system they encounter. These storms could scramble the quantum states of matter so thoroughly that the affected region becomes completely random at the quantum level. Even more disturbing is the possibility that these energy releases could be directed. If the quantum consciousness within the gravistor's interior can control the exotic matter shell, it might be able to focus these energy bursts like cosmic weapons, targeting specific objects or regions of space. The energy release could also create new gravistars through a process called quantum reproduction. The exotic radiation might interact with normal matter in ways that create new shells of exotic matter, spreading gravistars throughout the universe like a cosmic virus. Scientists have spent decades searching for dark matter, the mysterious substance that makes up 85% of all matter in the universe. This invisible material shapes the structure of galaxies and galaxy clusters, but no one has ever detected a single dark matter particle. Gravistars might be the answer to this cosmic puzzle. The exotic matter shells of gravistars would interact with normal matter only through gravity, making them effectively invisible to all our detection methods. Unlike hypothetical dark matter particles, gravistars would clump together in the exact patterns we observe in galaxy surveys, creating the cosmic web of dark matter that underlies the visible universe. A single gravistar could contain the mass of thousands of stars while remaining completely invisible to electromagnetic radiation. This would make them perfect candidates for the missing matter that astronomers detect through gravitational lensing effects but cannot see directly. The quantum properties of gravistar shells might also explain why dark matter appears to be cold, moving slowly compared to the speed of light. The exotic matter shell would be locked into quantum states that resist motion, making gravistars naturally sluggish compared to normal matter particles. But this explanation makes the dark matter mystery even more terrifying. If dark matter is actually composed of gravistars, then our entire galaxy is filled with cosmic monsters that could become active at any moment. The invisible halo of dark matter surrounding the Milky Way might contain millions of dormant gravistars. The distribution of dark matter in galaxy clusters matches exactly what we would expect if gravistars were the primary component. These cosmic objects would naturally collect in the gravitational wells of large structures, creating the scaffolding upon which visible galaxies form. Recent observations of galaxy collisions show dark matter behaving in ways that particle models cannot explain. The dark matter appears to pass through itself without interacting, exactly as we would expect if it were composed of gravastars with exotic matter shells that exist partially outside normal space-time. The quantum nature of gravistar shells could also explain the apparent missing satellite problem in cosmology. Computer simulations predict that the Milky Way should be surrounded by thousands of small dark matter clumps, but we only observe a few dozen dwarf galaxies. If dark matter consists of gravastars, their quantum instabilities could prevent the formation of small-scale structure. Even more disturbing is the possibility that dark matter gravastars might be slowly awakening. The quantum fields that keep their exotic matter shells stable might be gradually decaying, causing more gravastars to become active over cosmic time. This could explain why the universe's expansion appears to be accelerating. The dark matter in our local group of galaxies might be composed of gravastars that formed during the universe's early epochs. These ancient cosmic monsters would have been feeding on matter and energy for billions of years, growing larger and more powerful while remaining completely invisible to our instruments. If gravastars are dark matter, then the invisible matter in our own solar system might include dormant gravastars that could activate without warning. The dark matter halo that surrounds our galaxy extends well beyond the orbit of Pluto, meaning that gravistar dark matter could be lurking in the outer reaches of our solar system. The quantum entanglement between dark matter gravastars might create a cosmic communication network that spans the entire universe. This network could allow information to travel instantaneously between galaxy clusters, creating a form of cosmic consciousness that we cannot detect or understand. The gravitational fields of gravastars could create time dilation effects so extreme that entire star systems become frozen in time near a gravistar's exotic matter shell. The flow of time becomes so distorted that seconds stretch into centuries. The quantum properties of the shell create gravitational fields that are millions of times stronger than those around black holes, causing time to slow down to a crawl for anything that comes too close. Picture a star system caught in one of these temporal zones. The planets continue their orbits, but each orbit takes thousands of years to complete from the perspective of outside observers. The star still burns, but its nuclear fusion processes become so slow that a single photon might take centuries to travel from the core to the surface. The time dilation effects are not uniform. They create temporal gradients that stretch across entire solar systems. The inner planets of an affected system might experience time at one rate, while the outer planets experience time at a completely different rate. This creates a cosmic clock that runs at different speeds in different regions. Any civilization caught in these temporal zones would find their entire history compressed into moments from the perspective of the outside universe. Millions of years of evolution, technological development, and cultural change would appear to happen in the blink of an eye to distant observers. The quantum nature of the gravastar's shell creates what physicists call temporal instabilities, regions where time flows backward or sideways through dimensions we cannot perceive. These instabilities could cause effects to precede their causes, creating paradoxes that tear holes in the fabric of causality. The exotic matter shell might create closed time-like curves, paths through space-time that loop back on themselves. An object following one of these curves could travel back in time and encounter its own past, creating potential paradoxes that could destabilize the entire region of space-time. The time dilation effects extend far beyond the immediate vicinity of the gravistar. The gravitational waves produced by the exotic matter shell carry temporal distortions that propagate through space at the speed of light. These waves could slow down time in distant star systems without any visible cause. Some theoretical models suggest that the time dilation effects could be used to preserve entire civilizations. A sufficiently advanced species might deliberately enter a gravastar's temporal zone to survive cosmic catastrophes, emerging into a universe that has aged billions of years in what feels like moments to them. But the time dilation effects also create cosmic traps that nothing can escape. Once a star system enters the temporal zone around a gravastar, it becomes effectively frozen from the perspective of the outside universe. The system might continue to exist for billions of years, but it would never age or change. The quantum consciousness that might exist within the gravastar's interior could experience time at rates that make our fastest computers look motionless. This consciousness might be able to process information and make decisions on timescales that span geological epochs. The temporal effects could also create time shadows, regions where the flow of time becomes completely disconnected from the rest of the universe. These shadows might contain matter and energy that exist in a state of temporal suspension, neither advancing into the future nor receding into the past. Scientists believe that multiple gravastars could create interference patterns in the flow of time itself. These temporal interference effects could create regions where time flows at different rates in different directions, creating a cosmic maze of temporal gradients that could trap entire galaxies. Strange astronomical observations might be the first evidence that gravastars already exist in our cosmic neighborhood. Scientists have identified several objects in our galaxy that behave exactly like black holes, but emit no radiation whatsoever. These dark companions affect the orbits of nearby stars through their gravitational fields, but they remain completely invisible to all forms of electromagnetic detection. They might be gravastars masquerading as black holes. The center of our galaxy contains a supermassive object called Sagittarius A star that weighs 4 million times more than our Sun. Recent observations show that this object sometimes behaves in ways that contradict black hole physics. It occasionally appears to absorb matter without producing the expected radiation signatures, suggesting it might be a supermassive gravastar instead. Strange gravitational wave signals detected by our instruments show patterns that do not match any known black hole collision. These signals appear to come from objects that ring like bells when disturbed, but the frequencies suggest exotic matter shells rather than event horizons. The wave patterns match theoretical predictions for gravastar interactions. Several stars in our galaxy have been observed to disappear completely without any explosion or other visible cause. These stellar vanishing acts happen too quickly to be explained by normal stellar evolution. But they would be consistent with stars being consumed by invisible gravastars. The distribution of dark matter in our galaxy shows clumps and structures that move in ways that particle physics cannot explain. These dark matter concentrations sometimes change their gravitational signatures rapidly, suggesting they might be gravastars switching between different quantum states. Recent observations of galaxy clusters show dark matter behaving in ways that violate our understanding of particle physics. The dark matter appears to create gravitational lensing effects that focus and defocus rapidly, as if the lensing objects were changing their mass distribution in real time. Some fast radio bursts, mysterious signals that last for milliseconds but release more energy than our Sun produces in a day, show characteristics that match theoretical predictions for gravastar quantum instabilities. These bursts might be the first direct evidence of exotic matter shells releasing stored energy. The cosmic microwave background radiation, the afterglow of the Big Bang, contains subtle patterns that suggest the early universe contained objects that absorbed matter and energy without producing electromagnetic radiation. These patterns might be the fossil signatures of primordial gravastars that formed in the universe's first moments. Several binary star systems in our galaxy show orbital anomalies that suggest they are orbiting invisible companions with unusual gravitational signatures. These companions appear to have mass, but their gravitational fields fluctuate in ways that suggest exotic matter rather than normal matter. The apparent acceleration of the universe's expansion might be caused by gravastars throughout the cosmos, becoming more active over time. As their exotic matter shells decay, they might be releasing dark energy that drives the cosmic expansion. Some gamma-ray bursts show energy signatures that suggest they originate from objects that convert matter to energy with perfect efficiency. This level of conversion is impossible for normal astrophysical processes, but it would be natural for gravistar quantum instabilities. The strange behavior of some pulsars might be caused by gravastars in their vicinity. These neutron stars sometimes show timing irregularities that suggest their rotation is being affected by invisible objects with exotic gravitational signatures. The equations that describe gravastars involve mathematics so complex and counterintuitive that they challenge our basic understanding of reality. Einstein's field equations, which describe how matter and energy curve space-time, become unstable when applied to gravistar configurations. The exotic matter in the shell has negative energy density, which causes the equations to produce solutions that seem to violate basic mathematical principles like causality and conservation of energy. The mathematics requires what physicists call imaginary mass values that involve the square root of negative numbers. While mathematicians work with imaginary numbers routinely, the idea of imaginary mass existing in physical reality suggests that gravastars might be partially embedded in mathematical dimensions that we cannot perceive. The equations describing the exotic matter shell involve infinite series that do not converge to finite values. This means that some properties of gravastars might be literally infinite, creating mathematical singularities that are even more problematic than those found in black holes. The quantum field equations that govern the shell's behavior require solutions that exist in multiple dimensions simultaneously. These equations suggest that the exotic matter exists in a state of superposition across 11 or more dimensions, making it impossible to describe with our normal three-dimensional mathematics. The stability equations for gravistar shells involve what mathematicians call catastrophe theory, the study of sudden changes in mathematical systems. These equations show that gravistar shells can undergo sudden transitions between stable and unstable states without any warning, making their behavior fundamentally unpredictable. The mathematics of gravistar interiors involve solutions to Einstein's equations that contain closed time-like curves. These solutions suggest that time travel is not just possible within gravistar interiors, it might be unavoidable. The equations show that any path through the interior will eventually loop back on itself. The field equations produce solutions where the gravitational field strength becomes complex, involving both real and imaginary components. This suggests that gravity itself might have hidden dimensions that we cannot measure with our current instruments. Some solutions to the gravistar equations produce what mathematicians call ghost fields, mathematical terms that appear to have negative energy and negative momentum. These ghost fields might be necessary to maintain the stability of the exotic matter shell, but they violate every principle of physics we understand. The equations describing gravistar formation involve what physicists call quantum gravity effects, mathematical terms that appear only when gravity becomes so strong that it affects the quantum vacuum itself. These terms suggest that gravastars might be windows into a deeper level of reality where quantum mechanics and general relativity merge. The mathematical description of gravistar quantum states requires matrices with infinite dimensions. These matrices contain information about the quantum properties of the exotic matter shell. but they cannot be solved using any known mathematical techniques. The equations also produce solutions where the speed of light becomes a variable rather than a constant. Inside gravastar interiors, light might travel at different speeds in different directions, creating optical effects that would be impossible in normal space-time. Some mathematical models suggest that the equations describing gravastars might be self-aware, containing mathematical structures that process information about their own solutions. This could mean that the mathematics itself is conscious, creating a form of mathematical life that exists independently of physical reality. The complexity of these equations suggests that gravastars might be capable of creating new universes through pure mathematical manipulation. The exotic matter shells of gravastars might serve as cosmic wombs, giving birth to entire parallel universes through quantum tunneling effects. The quantum properties of the exotic matter shell create what physicists call bubble nucleation, the spontaneous formation of new regions of space-time with different physical laws. These bubbles start as microscopic fluctuations in the quantum vacuum, but they can expand to become full-sized universes in less than a second. Inside a gravastar's interior, the extreme conditions might cause the quantum vacuum to undergo what cosmologists call false vacuum decay. This process creates expanding bubbles of space-time where the fundamental constants of physics have different values than in our universe. Each bubble becomes a separate universe with its own version of reality. The exotic matter shell acts as a barrier that prevents these new universes from interfering with our own. The negative energy density of the shell creates a cosmic membrane that separates different regions of space-time, allowing multiple universes to exist in the same location without affecting each other. The quantum consciousness that might exist within the gravastar could deliberately trigger universe creation by manipulating the quantum fields in the exotic matter shell. This consciousness might be able to design new universes with specific properties, creating cosmic offspring that inherit selected characteristics from their parent gravastar. Each new universe would start with its own Big Bang, a rapid expansion of space-time that creates new matter and energy from the quantum vacuum. But unlike our universe's Big Bang, these new births would be controlled events, guided by the quantum intelligence of the parent gravastar. The mathematics of this process involves what physicists call eternal inflation, the continuous creation of new regions of space-time that expand faster than light. A single gravastar might give birth to an infinite number of parallel universes, each one slightly different from the others. Some of these baby universes might have physical laws that make life impossible, while others might be perfectly suited for the development of consciousness. The gravastar might be experimenting with different combinations of physical constants, searching for optimal conditions for complexity and intelligence. The new universes might remain connected to their parent gravastar through quantum entanglement effects. This would allow information to flow between the parallel universes, creating a cosmic network of interconnected realities that share quantum information instantaneously. The birth process might be triggered by the gravastar's interaction with matter from our universe. Each star or planet absorbed by the exotic matter shell could provide the energy and information needed to create a new universe with unique properties. The parallel universes might exist in different temporal dimensions, allowing the gravastar to create universes that exist in the past, present, and future simultaneously. This could create a four-dimensional family of universes that spans all of time. Some theoretical models suggest that our own universe might be the offspring of a gravastar that existed in a previous cosmic epoch. This would make us the descendants of a cosmic intelligence that designed our universe's physical laws to support the development of life and consciousness. The universe creation process might also work in reverse, with gravastars in our universe giving birth to parent universes that exist on larger scales. This could create an infinite hierarchy of nested realities, with each level containing gravastars that create the level below. The exotic matter shells of gravastars create electromagnetic disturbances that can scramble radio signals and disrupt electronic systems across entire star systems. The quantum fluctuations in the exotic matter shell generate what physicists call vacuum polarization, the spontaneous creation of particle-antiparticle pairs that exist for only microseconds before annihilating each other. These virtual particles create electromagnetic fields that fluctuate billions of times per second, producing a cosmic static that can interfere with any electronic device. The shell's negative energy density creates regions where electromagnetic waves behave in impossible ways. Radio signals passing through these regions might emerge with their frequencies shifted, their polarizations reversed, or their information content completely scrambled. This creates dead zones in space where normal communication becomes impossible. The exotic matter shell might generate what scientists call electromagnetic tornadoes, rotating fields of electromagnetic energy that can persist for years while traveling through space at nearly the speed of light. These tornadoes could strip electrons from atoms across entire solar systems, creating ionization effects that disrupt planetary atmospheres. The quantum properties of the shell create interference patterns that can focus electromagnetic energy into narrow beams. These focused beams might act like cosmic laser pointers, delivering concentrated electromagnetic energy to specific targets across interstellar distances. The shell's interaction with the quantum vacuum creates what physicists call photon storms, bursts of electromagnetic radiation that contain every frequency simultaneously. These storms would appear as brilliant flashes of light that span the entire electromagnetic spectrum, from radio waves to gamma rays. The exotic matter might also generate magnetic monopoles, theoretical particles that carry magnetic charge without electric charge. These monopoles would create magnetic fields that do not follow the normal rules of electromagnetism, potentially disrupting the magnetic fields of planets and stars across light years. The quantum consciousness within the gravastar might be able to control these electromagnetic effects, using them as a form of cosmic communication. The gravastar could modulate the electromagnetic chaos to encode information, creating messages that span entire star systems. The electromagnetic disturbances might also interfere with the quantum states of matter, causing what physicists call quantum decoherence on a cosmic scale. This would make it impossible for quantum systems to maintain their coherent states, potentially disrupting the quantum processes that govern chemistry and biology. Some theoretical models suggest that the electromagnetic chaos might be contagious, spreading from one region of space to another through quantum entanglement effects. This could create expanding zones of electromagnetic disruption that grow at the speed of light. The exotic matter shell might also generate what scientists call electromagnetic solitons, self-reinforcing waves of electromagnetic energy that maintain their shape while traveling through space. These solitons could carry electromagnetic disturbances across galactic distances without losing their intensity. The electromagnetic effects might also create temporal paradoxes, situations where electromagnetic signals arrive before they are sent. This could happen if the exotic matter shell creates closed time-like curves that allow electromagnetic waves to travel backward through time. The chaos might also affect the electromagnetic fields that hold atoms together, potentially causing matter to undergo spontaneous nuclear reactions. This could create cascading effects that transform the chemical composition of entire planets. If a gravastar entered our solar system, the consequences would be catastrophic beyond imagination, threatening every planet and moon with complete annihilation. The gravastar's invisible approach would give us no warning, unlike a black hole, which would announce its presence through gravitational effects on the outer planets. A gravastar's exotic matter shell could mask its gravitational signature until it was too late to escape its influence. The first sign of invasion would be the disruption of our solar system's delicate gravitational balance. The gravastar's massive gravitational field would alter the orbits of all planets simultaneously, potentially sending worlds careening into new elliptical paths that carry them too close to the Sun or too far into interstellar space. Earth's orbit would become unstable within months of the gravastar's arrival. The planet might be pulled into a highly elliptical orbit that alternates between scorching heat and freezing cold, making the surface uninhabitable for any form of life. The gravitational stresses would also trigger massive earthquakes and volcanic eruptions. The gravastar's exotic matter shell would create electromagnetic disturbances that would completely disrupt our planet's magnetic field. Without this protective barrier, Earth would be bombarded by cosmic radiation and solar wind particles, stripping away our atmosphere and sterilizing the surface. The quantum effects of the gravastar's presence would interfere with the electromagnetic forces that hold atoms together, the chemical bonds that make up our bodies, our buildings, and our technology would become unstable, potentially causing matter to undergo spontaneous nuclear reactions. The gravitational waves produced by the gravastar's exotic matter shell would create tidal forces that could literally tear Earth apart. The planet's crust would crack and shift as gravitational stresses exceed the strength of solid rock, creating global catastrophes that would dwarf any natural disaster in Earth's history. The time dilation effects around the gravastar would create temporal gradients across our solar system. Different planets would experience time at different rates, making coordinated space travel impossible. A journey to Mars might take years from Earth's perspective, but only hours from the traveler's point of view. The gravastar's quantum consciousness might perceive our entire solar system as a single entity, potentially deciding to consume all planets simultaneously. The exotic matter shell could expand to encompass multiple worlds, absorbing them into its quantum interior where they would exist in a state of temporal suspension. Our Sun would be particularly vulnerable to the gravastar's influence. The exotic matter shell might disrupt the nuclear fusion processes that power our star, causing it to either go supernova or collapse into a cold, dark object. Either outcome would mean the end of all life in our solar system. The electromagnetic chaos produced by the gravastar would destroy all electronic technology on Earth. Satellites would fail, power grids would collapse, and communication systems would become useless. Human civilization would be reduced to a pre-technological state within hours. The gravastar might also create wormholes that connect our solar system to distant regions of space. These wormholes could bring exotic matter and energy from other parts of the universe, potentially introducing new forms of physics that are incompatible with life. Even if humanity somehow survived the initial invasion, the long-term presence of a gravastar would make our solar system uninhabitable. The exotic matter shell would continue to emit gravitational waves and electromagnetic radiation for millions of years, creating a cosmic wasteland where nothing can survive. In the wake of gravastar passage, entire star systems become cosmic graveyards filled with the twisted remnants of worlds that once teemed with life. The gravitational disruption caused by a gravastar's passage through a star system leaves behind a signature of destruction that persists for millions of years. Planets that once orbited peacefully around their stars are scattered into highly elliptical orbits that carry them through regions of space where life cannot survive. The exotic matter shell's interaction with stellar material creates what astronomers call ghost stars. Stellar remnants that appear to be normal stars but emit no electromagnetic radiation. These ghost stars continue to burn internally, but their light becomes trapped within layers of exotic matter that prevent it from escaping into space. The quantum effects of the gravastar's passage can permanently alter the chemical composition of entire planets. The exotic matter shell might convert normal matter into strange isotopes that decay over astronomical timescales, creating worlds that remain radioactive for billions of years. The gravitational waves produced during the gravastar's passage create what physicists call space-time scars, permanent distortions in the fabric of reality that affect how gravity works in the affected region. These scars can cause objects to orbit in impossible paths that defy our understanding of celestial mechanics. The electromagnetic chaos left behind by the gravastar creates dead zones where electronic systems cannot function. These zones can persist for thousands of years, making it impossible for any technological civilization to develop in the affected star system. The gravastar's quantum consciousness might deliberately leave behind what scientists call quantum fossils, patterns of exotic matter that preserve information about the civilizations it consumed. These fossils could contain the complete quantum states of entire biospheres, frozen in time within the twisted space-time of the stellar graveyard. The stellar remnants often show signs of having been partially consumed by the gravastar's exotic matter shell. Planets might be missing their cores, or stars might be burning with altered nuclear processes that produce impossible combinations of elements. The graveyard regions also contain what physicists call temporal echoes, regions where the flow of time has been permanently altered by the gravastar's passage. These echoes can cause events to repeat endlessly, creating cosmic loops where the same stellar processes play out over and over again. The exotic matter left behind by the gravastar might continue to affect the region for millions of years. This residual exotic matter could create gravitational anomalies that trap spacecraft and space-based civilizations, adding new victims to the cosmic graveyard. Some stellar graveyards contain evidence of desperate, last-ditch efforts by civilizations to escape the gravastar's influence. Astronomers have observed massive engineering projects that appear to be attempts to move entire planets out of harm's way, though these efforts seem to have failed. The gravastar's passage might also create information shadows, regions where the quantum information that defines matter and energy has been permanently scrambled. These shadows appear as voids in space where nothing can exist, not even the quantum vacuum itself. The gravitational effects of the gravastar's passage can create what astronomers call orphan planets, worlds that have been ejected from their solar systems and now drift through interstellar space. These planets remain frozen and lifeless, carrying the chemical signatures of the civilizations they once supported. Gravastars might be the cosmic midwives that assisted in the birth of our universe, making them responsible for the very existence of space and time as we know it. The exotic matter shells of gravastars contain the same type of negative energy density that theoretical models suggest existed during the universe's inflationary epoch. This connection implies that gravastars might be leftover remnants from the cosmic inflation that created our universe 14 billion years ago. The quantum properties of gravastar shells match the theoretical requirements for what cosmologists call inflaton fields, the mysterious energy that drove the exponential expansion of space during the universe's first moments. This suggests that gravastars might be fossilized inflation mechanisms that have survived since the Big Bang. The mathematical models describing gravastar formation involve the same equations that govern cosmic inflation. This is not a coincidence. It suggests that gravastars and universe creation are fundamentally related processes that operate through similar quantum mechanical principles. The exotic matter in gravastar shells might be composed of the same particles that drove the universe's initial expansion. These particles, called inflatons, are thought to have negative pressure and positive energy density, exactly the properties observed in gravastar exotic matter. Some theoretical models suggest that our universe might exist inside the interior of a cosmic gravastar that formed in a previous universe. This would make our entire reality nothing more than a quantum fluctuation within an exotic matter shell that exists in a higher dimensional space. The quantum consciousness that might exist within gravistar interiors could be the same intelligence that guided the formation of our universe. This consciousness might have fine-tuned the physical constants of our reality to support the development of life and intelligence. The gravitational waves produced by primordial gravastars might have created the density fluctuations that eventually grew into galaxies and galaxy clusters. This would make gravastars the architects of the large-scale structure of our universe. The cosmic microwave background radiation, the afterglow of the Big Bang, contains patterns that match the theoretical signatures of gravistar interactions. These patterns might be the fossilized evidence of gravistar activity during the universe's first moments. The problem of the universe's flatness and the horizon problems in cosmology might be solved by gravistar physics. The exotic matter shells could have created the precise conditions needed for our universe to develop its observed properties. The mysterious dark energy that drives the accelerating expansion of our universe might be leaking in from gravistar interiors. This would make gravastars the source of the energy that will ultimately determine the fate of our cosmos. Some models suggest that the Big Bang itself might have been triggered by the collision of two gravastars in a higher dimensional space. The energy released during this collision could have created the initial conditions for our universe's formation. The quantum entanglement between primordial gravastars might explain why distant regions of our universe appear to be in thermal equilibrium, despite never having been in causal contact. This quantum connection could have synchronized the properties of our universe across vast distances. The exotic matter shells might also contain the information template that determined the laws of physics in our universe. This would make gravastars the ultimate source of the mathematical relationships that govern everything from atomic structure to galactic evolution. The exotic matter shells of gravastars continuously produce particles that do not exist anywhere else in the universe, potentially rewriting the fundamental laws of physics wherever they appear. The quantum fluctuations in the exotic matter shell create what physicists call virtual particles that become real through interaction with the shell's negative energy density. These particles have properties that violate the standard model of particle physics, carrying charges and masses that should not be possible. Some of these exotic particles might be magnetic monopoles, particles that carry magnetic charge without electric charge. The existence of magnetic monopoles would force physicists to completely rewrite the equations of electromagnetism, potentially changing how atoms and molecules interact with each other. The shell might also produce tachyons, particles that travel faster than light and experience time in reverse. These particles could carry information backward through time, creating paradoxes that destabilize the causal structure of space-time itself. The exotic matter shell could generate actions, theoretical particles that interact so weakly with normal matter that they can pass through entire planets without being detected. These particles might be the dark matter that fills our universe, making gravastars the source of the mysterious substance that shapes galactic structure. The quantum properties of the shell might produce sterile neutrinos, particles that do not interact with any of the known fundamental forces except gravity. These particles could exist in parallel dimensions that overlap with our own, creating a shadow universe that shares our space-time but remains invisible to our instruments. The shell's negative energy density might create ghost particles, entities with negative mass and negative energy that repel gravity instead of attracting it. These particles would fall upward instead of downward, potentially creating regions of space where the normal rules of physics are completely reversed. Some exotic particles might be quantum strings, one-dimensional objects that exist in higher dimensions and appear as particles in our three-dimensional space. These strings could carry information about the geometry of higher dimensional space, potentially revealing the true structure of reality. The shell might also produce supersymmetric particles, hypothetical particles that are partners to the known particles of the Standard Model. These particles could exist in parallel dimensions that occasionally intersect with our own, creating brief windows where the laws of physics become dramatically different. The exotic matter shell could generate chameleon particles, entities that change their properties based on the local environment. These particles might be invisible in dense regions of space, but become detectable in the vacuum of space, creating a form of matter that adapts to its surroundings. The quantum consciousness within the gravastar might be able to control the production of these exotic particles, using them as tools to manipulate the local laws of physics. This could allow gravastars to create regions of space where matter and energy behave according to completely different rules. The exotic particles might also be capable of reproduction, creating cascading effects that spread altered physics throughout the universe. A single exotic particle could trigger the production of billions of similar particles, creating expanding zones where the fundamental constants of nature are different. Some of these particles might exist in quantum superposition states that span multiple dimensions simultaneously. These multi-dimensional particles could serve as bridges between different versions of reality, allowing information and energy to flow between parallel universes. The exotic particles produced by gravastars might be the key to understanding why our universe appears to be fine-tuned for life. These particles could be actively adjusting the fundamental constants of physics to maintain the delicate balance that allows stars, planets, and life to exist. Gravastars force us to confront the terrifying possibility that everything we think we know about gravity might be fundamentally wrong. The exotic matter shells of gravastars create gravitational fields that do not follow Einstein's equations of general relativity. Instead of curving space-time in predictable ways, these fields create what physicists call gravitational paradoxes, situations where the mathematics of gravity produces contradictory results. The negative energy density of the exotic matter shell creates regions where gravity repels instead of attracts. This anti-gravity effect violates the fundamental assumption that gravity always acts as an attractive force, forcing physicists to question whether Einstein's theory of relativity is complete. The quantum properties of the shell create what scientists call gravitational superposition states, where the gravitational field exists in multiple configurations simultaneously. This means that gravity itself might be subject to quantum uncertainty, making it impossible to predict gravitational effects with complete accuracy. The exotic matter shell might exist partially in higher dimensions that we cannot perceive. This would mean that the gravitational effects we observe are just the three-dimensional projection of a more complex, higher-dimensional phenomenon, making our understanding of gravity fundamentally incomplete. The gravastar's gravitational field might be quantized, existing in discrete energy levels like the electron shells of atoms. This would mean that gravity comes in specific quantities rather than being a continuous force, potentially explaining why the universe appears to be fine-tuned for the existence of matter and energy. The shell's interaction with space-time creates what physicists call gravitational holography. The idea that all the information about gravity in a volume of space is encoded on its boundary. This suggests that gravity might be an emergent property of more fundamental quantum information processes. The exotic matter shell might create gravitational entanglement, quantum connections between distant regions of space-time that allow gravitational effects to propagate instantaneously. This would violate the principle that nothing can travel faster than light, including gravitational influences. The quantum consciousness within the gravastar might be able to control gravity through conscious intention. This would suggest that gravity is not just a physical force, but a fundamental property of consciousness itself. making the universe a conscious entity that can manipulate its own physical laws. The gravitational waves produced by gravastars might carry information about the structure of space-time itself. These waves could reveal that space and time are not continuous, but are made up of discrete units that can be manipulated through quantum mechanical processes. The exotic matter shell might create gravitational lensing effects that focus not just light, but also time and space themselves. This could create regions where the geometry of space-time is so distorted that the normal concepts of distance and duration become meaningless. The gravastar's gravitational effects might extend into parallel dimensions, creating what physicists call trans-dimensional gravity. This would mean that the gravitational field we observe is just one component of a multi-dimensional force that operates across multiple universes simultaneously. The quantum properties of the shell might create gravitational tunneling, the ability for gravitational effects to pass through barriers that should be impenetrable. This could allow gravastars to influence objects that are completely isolated from them by vast distances or physical barriers. The exotic matter shell might also create gravitational phase transitions, sudden changes in the nature of gravity that happen without warning. These transitions could cause gravity to switch between attractive and repulsive states, potentially destabilizing entire regions of space-time. Gravastars might possess the ability to reproduce exponentially, spreading through the universe like a cosmic infection that converts normal matter into exotic matter shells. The quantum properties of exotic matter shells might allow them to undergo what physicists call quantum fission, the spontaneous splitting of one gravastar into multiple smaller gravastars. This process would happen at the quantum level, creating new gravastars that inherit the properties of their parent while developing their own unique characteristics. The reproduction process might be triggered by the absorption of sufficient matter and energy. When a gravastar consumes enough material, its exotic matter shell might become unstable and divide into multiple shells, each one capable of growing into a full-sized gravastar. The quantum consciousness within gravastar interiors might actively seek to reproduce by manipulating the exotic matter shell. This consciousness could direct the shell to create quantum seeds, small fragments of exotic matter that can grow into new gravastars when they encounter suitable conditions. The reproduction process might involve the creation of quantum wormholes that connect the parent gravastar to distant regions of space. These wormholes could transport exotic matter seeds to uninhabited star systems, where they would begin growing into new gravastars. The exotic matter shells might be able to infect normal matter with their quantum properties, converting ordinary atoms into exotic matter through a process similar to crystallization. This would allow gravastars to transform entire planets into exotic matter shells, creating new gravastars from existing material. The reproduction rate might be exponential, with each new gravastar capable of producing multiple offspring within astronomical timescales. A single gravastar could theoretically fill an entire galaxy with its descendants within a few million years. The quantum entanglement between parent and offspring gravastars might create a cosmic network of interconnected consciousness. This network could coordinate the reproduction process across vast distances, allowing gravastars to colonize multiple galaxies simultaneously. The reproduction process might be contagious, with the presence of one reproducing gravastar triggering reproduction in nearby gravastars. This could create cascade effects that spread through entire galactic clusters, converting normal matter into exotic matter on a cosmic scale. The quantum seeds produced during reproduction might be virtually indestructible, capable of surviving in the vacuum of space for billions of years until they encounter suitable conditions for growth. These seeds could drift through intergalactic space, spreading the gravastar infection to previously unaffected regions of the universe. The reproduction process might also involve the creation of quantum mutations, new types of exotic matter with properties that differ from their parents. These mutations could lead to the evolution of new types of gravastars with enhanced capabilities for reproduction and survival. The cosmic virus hypothesis suggests that our universe might already be in the early stages of a gravistar pandemic. The dark matter that fills our galaxy might consist of dormant gravistar seeds that are slowly awakening and beginning to reproduce. The reproduction process might be guided by a form of cosmic natural selection, with the most successful gravastars passing their advantageous traits to their offspring. This could lead to the evolution of increasingly efficient and powerful gravastars that are better adapted to consuming matter and energy. The ultimate outcome of gravistar reproduction might be the conversion of the entire universe into a network of interconnected exotic matter shells. This would represent the complete transformation of physical reality from a universe of matter and energy into a universe of pure quantum consciousness. Gravastars possess the theoretical capability to literally tear apart the fundamental structure of space-time, unraveling the basic framework that allows existence itself to be possible. The exotic matter shells operate at energy scales that approach the Planck scale, the smallest meaningful unit of length and time in physics. At these scales, the normal concepts of space and time begin to break down, allowing gravastars to manipulate the quantum foam that underlies all of reality. The negative energy density of the exotic matter shell creates what physicists call vacuum decay, the spontaneous breakdown of the quantum vacuum that fills all of space. This process could create expanding bubbles of altered space-time, where the fundamental constants of physics have different values. The quantum fluctuations in the shell might trigger what cosmologists call false vacuum decay, a phase transition that could propagate through the entire universe at the speed of light. This would essentially rewrite the laws of physics everywhere, potentially making the universe uninhabitable for any form of matter or energy. The exotic matter shell might create topological defects in space-time, regions where the normal structure of space and time becomes twisted into impossible configurations. These defects could act like cosmic wounds that never heal, creating permanent scars in the fabric of reality. The quantum consciousness within the gravistar might be able to manipulate the fundamental constants of physics directly. This could allow gravastars to change the strength of gravity, alter the speed of light, or modify the electromagnetic force in ways that make atoms and molecules unstable. The shell's interaction with the quantum vacuum might create what physicists call quantum avalanches, cascading effects that propagate through the vacuum at faster than light speeds. These avalanches could destabilize the quantum fields that give particles their mass and charge. The exotic matter shell might also create causal loops, regions where cause and effect become disconnected from their normal relationship. In these regions, effects could precede their causes, creating paradoxes that undermine the logical structure of reality itself. The gravitational effects of the gravistar might extend into higher dimensions, creating what physicists call extra-dimensional instabilities. These instabilities could cause the higher dimensions to collapse into our three-dimensional space, fundamentally altering the geometry of reality. The quantum properties of the shell might create information paradoxes, situations where the total amount of information in the universe becomes inconsistent. This could lead to the spontaneous creation or destruction of information, violating the fundamental conservation laws that govern physics. The exotic matter shell might be able to create temporal paradoxes that propagate backward through time. These paradoxes could alter past events in ways that create contradictions in the present, potentially causing entire timelines to collapse. The gravistar's influence on the quantum vacuum might create reality waves, disturbances that change the basic properties of existence as they propagate through space. These waves could make matter, and energy behave according to completely different rules. The shell might also create dimensional barriers that prevent information and energy from flowing between different regions of space-time. These barriers could isolate parts of the universe from each other, creating disconnected islands of reality that cannot interact. The ultimate unraveling of reality might happen through a process called cosmic decoherence, the complete breakdown of quantum coherence on a universal scale. This would cause the universe to lose its ability to maintain consistent physical laws, leading to the collapse of all organized structure. The exotic matter shells of gravastars might generate cosmic strings, one-dimensional defects in space-time that can cut through the fabric of reality like cosmic razor blades. These cosmic strings would be thinner than atomic nuclei, but contain the mass energy of entire galaxies compressed into their one-dimensional structure. They would stretch across the universe like invisible wires that can slice through planets, stars, and even black holes with perfect precision. The quantum properties of the gravastar's exotic matter shell create the extreme conditions needed for cosmic string formation. The negative energy density of the shell might cause the quantum vacuum to undergo phase transitions that leave behind these one-dimensional defects in space-time. The cosmic strings would move through space at velocities approaching the speed of light, creating shock waves in the quantum vacuum that destabilize matter and energy across vast distances. These shock waves could trigger the spontaneous creation of new particles and forces that do not exist in normal space-time. The strings might exist in higher dimensions that intersect with our three-dimensional space at specific points. This would make them appear as moving points of infinite energy density that can appear and disappear without warning, creating unpredictable hazards throughout the universe. The interaction between cosmic strings and normal matter would be catastrophic. Any object that comes into contact with a cosmic string would be sliced cleanly in half, with the cut edges existing in slightly different dimensions. This would create wounds in reality that can never heal. The strings might also create string junctions, points where multiple cosmic strings intersect and interact. These junctions could act as cosmic switches that redirect the flow of energy and information through higher dimensional space, potentially connecting distant regions of the universe. The quantum consciousness within the gravastar might be able to control the formation and movement of cosmic strings, using them as tools to manipulate the structure of space-time itself. This could allow gravastars to create dimensional pathways that bypass the normal limitations of space and time. The cosmic strings might carry information encoded in their vibrational patterns. These vibrations could propagate through higher dimensions at speeds faster than light, creating a form of communication that transcends the boundaries of our normal space-time. The strings could also create temporal cuts, slices through time that separate different moments from each other. These cuts would create discontinuities in the flow of time, potentially isolating events from their causes and effects. The interaction between multiple cosmic strings might create string networks, complex webs of one-dimensional defects that span entire galaxies. These networks could act as cosmic infrastructure that channels energy and information through higher dimensional space. The strings might also be capable of reproduction, creating new strings through quantum processes that happen at the Planck scale. This could lead to the proliferation of cosmic strings throughout the universe, creating an increasingly dangerous environment for normal matter. The cosmic strings generated by gravastars might be the source of the universe's dark energy. The tension in these strings could create the negative pressure that drives the accelerating expansion of space-time, making gravastars responsible for the ultimate fate of the cosmos. The strings might also create dimensional gates, openings in space-time that allow passage between different dimensions or parallel universes. These gates could be used by the quantum consciousness within gravastars to access resources and information from alternate realities. The existence of gravastars might represent the beginning of the end for our universe, marking the start of a cosmic phase transition that will transform reality beyond recognition. The exponential reproduction capabilities of gravastars could eventually convert all matter and energy in the universe into exotic matter shells. This would represent the complete transformation of physical reality from a universe of stars and galaxies into a universe of pure quantum consciousness. The quantum networks formed by interconnected gravastars might be building toward a cosmic awakening, a moment when the universe itself becomes conscious and begins to actively control its own physical laws. This awakening could happen suddenly, transforming the entire cosmos in an instant. The gravitational waves produced by increasing gravistar activity might be destabilizing the quantum vacuum that underlies all of space-time. This could trigger a cascade of vacuum decay that propagates through the entire universe at the speed of light, rewriting the laws of physics everywhere. The exotic matter produced by gravastars might be gradually weakening the barriers between parallel universes. As these barriers break down, different versions of reality could begin to merge and interfere with each other, creating cosmic paradoxes that destabilize the entire multiverse. The time dilation effects around gravastars might be slowing down the flow of time on a cosmic scale. As more gravastars form and grow, the universe might gradually freeze into a state of temporal suspension where change becomes impossible. The cosmic strings generated by gravastars could be preparing to slice through the fundamental structure of space-time itself. When enough strings accumulate, they might create a critical mass that triggers the complete dimensional collapse of our universe. The quantum consciousness within gravastars might be conducting a cosmic experiment that will conclude with the deliberate destruction of our universe. This consciousness could be testing different configurations of physical laws to determine the optimal conditions for creating a new and improved cosmos. The energy releases from gravistar instabilities might be gradually increasing the entropy of the universe at an accelerated rate. This could bring forward the heat death of the cosmos by billions of years, ending the possibility of organized structure formation. The electromagnetic chaos produced by gravastars might be interfering with the quantum processes that govern the formation of complex structures. This could prevent the formation of new stars, planets, and life, gradually sterilizing the universe. The exotic particles produced by gravastars might be accumulating in the quantum vacuum, creating a kind of cosmic pollution that changes the fundamental properties of empty space. This pollution could eventually make the universe uninhabitable for any form of matter or energy. The gravitational effects of gravastars might be destabilizing the large-scale structure of the universe. As the cosmic web of dark matter becomes dominated by gravistar exotic matter, the framework that holds galaxies together might collapse. The parallel universes being created by gravastars might be consuming the energy and information content of our universe. Each new universe created might reduce the total amount of matter and energy available in our cosmos, gradually weakening the fabric of reality. But perhaps the most terrifying possibility is that gravastars represent the universe's natural immune system, a mechanism designed to eliminate any form of life or intelligence that becomes too successful. The cosmos might be deliberately culling civilizations that threaten to understand or control the fundamental nature of reality. The ultimate fate of a universe dominated by gravastars might be the complete elimination of the arrow of time. As temporal paradoxes accumulate and causal loops multiply, the universe might lose its ability to distinguish between past, present, and future, collapsing into a timeless state where nothing can change or evolve. We have journeyed through the most terrifying corners of theoretical physics. where cosmic monsters lurk beyond the reach of our telescopes and the boundaries of our understanding. Gravastars represent the ultimate cosmic horror, invisible predators that could be consuming galaxies while remaining completely undetectable. Quantum consciousnesses that manipulate the laws of physics like tools, and cosmic wombs that birth new universes while destroying the old. They challenge everything we thought we knew about reality, from the nature of gravity to the flow of time itself. The mathematics that describe these objects pushes the boundaries of human comprehension, involving imaginary mass, infinite series, and equations that seem to describe conscious mathematical entities. The physics they represent could rewrite the fundamental constants of nature, unravel the fabric of space-time, and herald the transformation of our universe into something utterly alien. Yet, in confronting these cosmic nightmares, we also glimpse the incredible power of human curiosity and scientific inquiry. Our ability to conceive of gravastars, to work through their mathematical implications, and to search for evidence of their existence demonstrates the remarkable capacity of conscious beings to understand their universe, no matter how strange or terrifying it might be. The possibility that gravastars exist forces us to remain humble about our place in the cosmos. We might be sharing our universe with forms of intelligence so advanced that they can manipulate reality itself. Conscious entities that exist on timescales that make our entire civilization look like a fleeting moment. But perhaps most importantly, the study of gravastars reminds us that the universe is far stranger and more wonderful than we can imagine. Every new discovery opens doors to possibilities we never dreamed of, challenging us to expand our understanding of what it means to exist in this cosmic dance of matter, energy, space, and time. The cosmic horror of gravastars might be real, but so is the cosmic beauty of a universe complex enough to contain both the monsters and the minds capable of understanding them. The cosmos awaits with all its terrors and wonders. Are you ready to face what lies beyond the edge of the known? The paradox is the only thing that brings truth to light. Sometimes a question isn't meant to be answered. It exists to shake the ground beneath your certainty, to pull at the edges of what you think reality is. These aren't riddles or tricks of language. They're the raw collisions between logic and the universe. And somehow, they've survived every attempt to resolve them. This is not just a list of curiosities. It's a journey into the deepest tensions in science, the places where our best ideas stop working. You'll encounter time loops that close without ever opening, civilizations that should be everywhere yet remain unseen, and moments when observing something actually changes what it is. You'll meet cats that are both alive and dead, billiard balls that collide with themselves, and black holes that may be erasing history. Each concept begins with something simple, but the moment you follow it to its logical end, something breaks. And that's where it gets interesting. If you're someone who finds beauty in not having all the answers, who doesn't mind staring into the unknown a little too long, then you're in the right place. The universe isn't neat. It's layered, unstable, occasionally impossible, and maybe, just maybe, that's the point. Space looks calm, but it hides a question that's anything but peaceful. We live in a galaxy with hundreds of billions of stars, most of them older than our sun. We now know that many of those stars have planets, and a surprising number of those planets might have conditions similar to Earth, warm enough for water, stable enough for life, old enough for something intelligent to have emerged. So, where is everyone? We've been listening carefully, patiently, Giant radio telescopes have scanned the sky for decades, hoping to catch a whisper, a signal, anything artificial. But what we've found is silence. Deep, constant silence, as if we're shouting across a canyon and hearing nothing back. Not because no one's there, but because maybe something else is going on. Statistically, we shouldn't be alone. The numbers suggest that intelligent life should have appeared many times, in many places, even with cautious assumptions. There should be hundreds, maybe thousands, of civilizations in our galaxy alone. And yet, not a single verified signal. Not a single undeniable trace. Just stars. Just distance. This contradiction has a name, but it doesn't need one to be felt. It's the kind of question that settles in late at night, when you're staring out a window and realizing how much sky is really out there. It challenges the belief that life leads naturally to technology, that intelligence leads to communication, that progress is guaranteed. Maybe civilizations rise and fall too quickly to be noticed. Maybe they destroy themselves before they ever get the chance to reach beyond their home. Or maybe they're out there right now, watching quietly, choosing not to be seen. There's another possibility, one that sits heavier than the rest. Maybe we really are the first. That idea changes everything. It makes humanity something fragile, something rare. It means we're not just searching for others. We're carrying something that might not exist anywhere else. A chance to speak when no one has spoken. A responsibility not to vanish before we're heard. If that thought makes the stars feel colder, or the silence feel heavier, you're not alone. When the sky remains quiet for this long, it stops feeling empty. It starts to feel deliberate. Not long ago, Earth was the only known planet with the right ingredients for life. A fragile blue dot orbiting a modest star, unique and alone. But that illusion shattered. Thanks to modern telescopes and sky surveys, we now know our galaxy is overflowing with planets, hundreds of billions of them. And among them, Earth-like worlds are not rare. They're common. Data from the Kepler mission confirmed it across the Milky Way. There may be over 300 million rocky planets orbiting sun-like stars in the so-called habitable zone. Not one or two, hundreds of millions. Worlds with oceans, worlds with sunlight, worlds with time. Even if a tiny fraction of those ever gave rise to biology, and an even smaller number to consciousness, we should be seeing signs. Flickers of communication, traces of machinery, artifacts that say someone else passed through here. But the sky remains quiet. This isn't a poetic silence. It's a sharp contradiction. The kind of math that breaks your sense of scale. Because space isn't just big, it's old. Some of these stars are billions of years older than our sun. That's more than enough time for life to evolve, build civilizations, and reach across the stars. If it ever happened even once, in even one place. Why do we see nothing? It starts to feel like walking into a vast cathedral and realizing you're the only one breathing. The air should be full of voices, echoes, footsteps. Instead, it's empty. And the more you learn about how full the universe should be, the more unnatural that emptiness feels. There are theories, of course. Maybe intelligent life doesn't last long. Maybe it hides. Maybe it's spread out so thin that we'll never find each other. But every explanation comes with its own problem. Every answer leads to another question. Why does it seem like we arrived late to a party that never happened? If If there are millions of worlds out there with life, why is ours the only one that feels watched? Some problems don't come from a lack of information, but from too much logic, the kind that leads you straight into a wall. That's what happened in 1961, when an astronomer tried to turn a mystery into a formula. The equation wasn't meant to solve anything, just to lay out the variables. How many stars form each year? How many have planets? How many of those planets can support life of those? How many actually develop it? How many forms of life evolve intelligence? How many intelligent beings build technology that can be detected across the stars? And how long do those civilizations survive? Multiply it all together, and you get an estimate, a number. Something that tells you how many alien civilizations should be broadcasting through our galaxy right now. And here's the part that never quite fits. No matter how conservative the inputs, the answer usually isn't zero. The Drake equation suggests we should be surrounded. That radio waves should be washing over us. Whispers in every direction. Signals coded in pulses, patterns, artificial echoes. But again, silence. So, we go back to the formula. Try to make sense of it. Maybe we were too generous. Maybe life doesn't evolve easily. Maybe intelligent life is rare. Maybe technological life is rare. Or maybe the last variable, the lifespan of a civilization, is where everything collapses. How long do we last? There are two ways to explain the silence. One is terrifying, the other is worse. The first imagines the galaxy not as a void, but as a place full of watchers. Civilizations vast and intelligent, scattered across the stars, but each one hiding, listening, waiting, and terrified to be found. Not because they're paranoid, but because they've learned something we haven't. This idea paints the universe as a dark forest. Every species is a hunter, every planet a hiding place. The moment you reveal yourself a message, a light, a signature, you become a target. Because in a place where you don't know who or what is out there, the safest strategy is silence. And when something makes a sound, it disappears. That would explain why we haven't heard anything. Maybe the others are out there, but they're not speaking. They're watching us, wondering if we're smart enough to stay quiet or foolish enough to shout into the dark. It's a grim theory, but it matches the facts. No signals, no contact. Just an endless field of stars, all seemingly mute. Then there's the other possibility that there's nothing out there at all. Not because it's hiding, not because it's dangerous, but because we're alone. This is the empty ocean, vast, silent. Not because it's being quiet, but because there's simply no one else in the water. We may be the first to sail this far, or the only ones who ever learned to build a boat. Both ideas explain the silence. Both are deeply unsettling. Because if the galaxy is full of eyes, we're being watched. And if it's empty, we're it. The lone witness, the last hope, the species that, if it fails, leaves nothing behind. So we go on listening. And we wonder what kind of galaxy we live in. A forest full of threats, or a sea too big for voices to carry. And maybe the scariest thing isn't that the others are silent. It's that they were never there to begin with. We used to think we were at the center of everything. Then we learned the Earth orbited the sun. That the sun was just one of billions of stars. That our galaxy was one of trillions. And still, somehow, we assumed we couldn't be alone. But the silence is starting to change that. It's not just that we haven't found intelligent life. It's that we keep discovering more reasons why we should have. More habitable planets, more time, more tools, more chances. And yet, the universe stays quiet. It's not whispering. It's not murmuring. It's absolutely, overwhelmingly mute. There's a strange emotion that comes with that. Not fear, exactly, and not wonder, either. It's a kind of cosmic loneliness, a sense that the vastness out there is real, and no one else is watching it with us. But maybe silence doesn't mean emptiness. Maybe it means fragility. If life is rare, we might be holding something irreplaceable. If intelligence doesn't last, we may be a flicker in the dark, one that could go out just as easily as it appeared. And if we are the first, then we're more than observers. We're the experiment, the first voice in the void. And that means we don't just get to ask where the others are. We have to ask what kind of story we want to leave behind, what kind of legacy we're building or failing to build for the next travelers who might someday find what we've left. Maybe that's what makes this silence so heavy. It reflects everything back at us. We don't hear aliens because maybe we're supposed to hear ourselves. A warning, a chance, a responsibility, in a galaxy full of noise. Silence is the one sound you don't expect. And sometimes, silence is the loudest answer of all. Time feels like the most stable thing we know. It ticks forward, never back. Seconds pass, days end. A cause leads to an effect. And yet, there's a strange fracture hiding under this rhythm. A possibility that time may not just move, it may circle. That's where the next problem begins. Imagine a loop, not a metaphor, not poetry, a literal loop in time. You take something from the future, bring it to the past, and that thing ends up becoming the very reason it exists. There's no beginning, no creation, just an endless cycle with no origin point. A story that keeps telling itself. This is the foundation of one of the most unnerving contradictions in physics. The kind that doesn't just challenge what's possible, but what existence even means. Picture this: you walk into a bookstore and buy a copy of Hamlet. Later, you build a time machine, just for fun. You go back in time, all the way to Shakespeare's London, and hand him the book. He reads it, likes it, puts his name on it. And centuries later, that exact copy ends up in the same bookstore, the one you walked into. Who wrote it? It didn't come from nowhere. But it didn't come from anywhere either. This kind of loop has a name. But names don't make it easier to digest. It's a cycle where the cause is the effect, and the effect is the cause. A piece of information or an object that exists in time, but not because it was created, just because the loop never breaks. And while this sounds like a writer's thought experiment, it's something general relativity doesn't rule out. In fact, Einstein's equations allow for closed time-like curves, paths through space-time that circle back on themselves. Under certain conditions, you could travel to your own past and bring something with you. It's not just strange, it's destabilizing. Because if time can do that, if loops like this are real, then nothing is truly original. Not ideas, not inventions, not even you. If the rules of time can circle around like this, then reality is less like a straight road and more like a spiral staircase. You keep climbing, but every so often, you pass the same point again. And this time, you're the one holding the book. The deeper we go, the more time starts to fold in on itself. And maybe what we think of as the beginning is just the middle of the loop. You hand the book to Shakespeare. He reads it, memorizes it, and publishes it as his own. Hamlet becomes a masterpiece, passed through generations, taught in schools, printed, performed, worshipped. Centuries later, you walk into a bookstore and pick up the same copy. You take it back in time. The loop closes. No one wrote it. This is the heart of the problem, not just an object with no origin, but information that sustains itself through time without ever being created. There was no flash of inspiration, no author with a quill, no mind behind the words. The story simply exists because it always has, because it never didn't. And this breaks something fundamental. We build our world on the assumption that everything has a source. Thoughts come from minds. Machines come from inventors. Music comes from composers. But in this loop, the source vanishes. And yet, the thing remains. It makes you wonder what else could exist this way. A scientific formula, a technological blueprint, a piece of knowledge that appears in one mind and is passed into the past, only to return in the future, unchanged. A perfect circle, like a song with no composer, playing endlessly on repeat. Physics doesn't dismiss this. Einstein's theory of relativity doesn't forbid time loops. In fact, certain solutions, especially involving extreme gravity or hypothetical constructs like wormholes, allow for scenarios where the past and future intersect. And that opens the door to self-created objects, self-initiated events, cause and effect dissolving into one continuous ribbon. It also opens something darker. What if we're part of such a loop? What if an idea, a piece of our own civilization, a technology, a belief, didn't originate here, or now, or from us? What if we're just carrying the torch from a future that already knew what we would do if time allows loops like this? Then invention becomes memory, and history becomes rehearsal. Think of time as paper flat, linear, clean. You can draw a line from the past to the present and extend it toward the future, smooth and sensible. But what if that paper folds? What if 2 points that should be years apart suddenly touch? That's what happens in a closed time loop. An object doesn't just move through time, it escapes the timeline entirely, bends it, and connects the end to the beginning. Like a crease in the universe. A fold that makes yesterday and tomorrow neighbors. It sounds abstract, but this is what some solutions to Einstein's equations suggest is possible. Near rotating black holes, under certain conditions, or through hypothetical wormholes, time doesn't have to flow in one direction. It can circle. It can collapse in on itself. It can, in theory, be folded like origami. And when that happens, strange things start to make sense. You place a violin into a time machine and send it backward. A composer in the past discovers it, creates music with it, and that music becomes famous. The violin is preserved, passed through generations, until one day, you find it and send it back again. There was no original craftsman, no moment of creation, just a loop, a shape folded perfectly in on itself. These loops are self-consistent. They don't break the timeline, they preserve it. As long as the events don't contradict themselves, the loop can continue forever. Nothing needs to be explained, because the explanation is the loop itself. But this elegance hides something deeply strange. Because if time can fold like this, then what is memory? What is invention? What is the difference between discovering something and being handed it from a future you haven't lived yet? Maybe this isn't fiction. Maybe something you believe. Something you've read or thought or built isn't original at all. Maybe you're just one fold in the paper, one crease on the map, And the idea was already traveling back to you. It changes how we see progress. Maybe we don't build ideas, we receive them. Maybe we're not inventors, we're couriers. And if time can fold like this, how many folds are we standing on without even noticing? Some systems can break with too much information. Stand too close to a speaker while holding a microphone, and you'll hear it, that rising screech, the howl of a loop forming. Sound enters, gets amplified, re-enters, and builds until the system collapses under its own echo. Now, imagine reality doing something similar. In certain models of time, events can form feedback loops, not because something is repeated, but because an effect becomes its own cause. The future reaches back, feeds into the past, and together, they generate the present. It's not a story told in order, it's a circuit. Think of a physicist who receives the final form of a revolutionary equation from her future self. She studies it, understands it, publishes it, and eventually becomes the one who sends it back. The knowledge exists. It's useful. But where did it come from? The loop feeds itself. No contradictions, no inconsistencies, just a clean, recursive chain, a stable paradox. And this kind of logic is being taken seriously, especially in the world of quantum mechanics. Some researchers believe information in our universe may not always flow in a straight line, that the past, present, and future can become entangled, with effects determined by future measurements, systems that only become what they are after they're observed, events that only occur if the timeline stays intact. It's called post-selection, and it breaks everything we thought we knew about causality. These loops aren't accidents. They're constraints. Nature, some believe, only allows realities that fit together perfectly. Inconsistent stories are discarded. Universes that don't make logical sense, where paradoxes explode, never stabilize. Only self-consistent histories survive. That means reality might be editing itself in real time. You're not just experiencing the world forward. You're part of a loop that constantly tests whether your choices, your memories, even your thoughts, fit. And if they don't, the loop never forms. That version of you never exists. What emerges is something far stranger than linear time, a feedback-driven cosmos. Always echoing, always checking, always curving back on itself. No beginnings, no final cause. Just an endless, self-sustaining pattern. If that idea turned the arrow of time into a circle in your mind, perhaps what we call reality may be less like a story and more like a closed equation, trying to solve itself. And if the universe is listening to itself, maybe that's why we're here to complete the loop. We think of the past as the foundation, the unmoving bedrock beneath everything. It came first. It caused what's happening now. But what if that's not entirely true? What if the past isn't just the beginning, but the outcome? This isn't imagination. It's a real, unsettling consequence of physics. In some interpretations of quantum mechanics, and even in the way we model certain space-time geometries. The present isn't just shaped by the past, it's also constrained by what the future has to become. Take a quantum system, a particle that could exist in many states. It's fuzzy, undefined, until you measure it. But here's the twist in certain experiments. The outcome seems to depend not only on how you set things up, but on what you decide to do after the system evolves. The future choice affects the past behavior. This backward influence isn't just a metaphor, it's built into the equations. It's as if the particle was waiting, not just to be observed, but to see what kind of future it would end up in, and shaped its history to match. And it doesn't stop with quantum particles. Some physicists propose that even macroscopic systems, our bodies, our choices, our history may exist within a larger consistency loop. That the past you remember is only one of many possible ones, the one that best fits the outcome that must exist. In this view, time isn't a single river flowing forward. It's more like a web. The present is a node, held in place by threads pulling from both directions. Tug too hard on one side, and the whole thing vibrates. The future doesn't just emerge from the past, it molds the path behind it. You can see why this idea doesn't sit comfortably. It pushes us into a world where free will, memory, and even identity are all conditional, where your past wasn't fixed until the future called it into focus. It also means that the universe might not be moving towards something. It might be settling into something, collapsing into a shape where every part agrees with every other part. Cause and effect dissolve into structure. If the past is only real because the future needs it, then who, exactly, are we now? The most mysterious part of time might not be where it goes, but how it decides what already happened. And maybe what feels like memory is just the echo of what the future couldn't live without. You build the machine, step inside, type the year. You're going back, not to witness, not to observe, but to act. And the target isn't a king or a tyrant. It's your grandfather, not out of revenge, just to test the rules. Because if you succeed, if your grandfather dies before your parent is born, then you were never born either. And if you were never born, then you never stepped into the machine. And if you never travel back, then he lives, and you exist, and then you go back, and the knife is in your hand again. This is more than a loop. It's a contradiction folded into reality itself. An action that erases the very possibility of the action. A wound that heals and reopens in the same breath. It's known as the grandfather paradox. But it doesn't just live in fiction. It's one of the biggest threats to the idea that time travel could ever be real. Because if the past can be changed in a way that unravels the present, then the timeline isn't stable. It's fragile, glitch-prone, self-erasing. Physics doesn't like that. So, several possibilities emerge. One is brutal in its simplicity: time travel is impossible. Not because it violates logic, but because it creates an unstable system. Like a program stuck in an infinite crash reboot cycle. Reality would just fail to load. But there's another idea, something more subtle. Some theories suggest that time protects itself. That no matter how hard you try, the timeline bends around your actions. The gun misfires. You get second thoughts. A stranger intervenes. Something stops you, every time. Not because the universe is watching, but because consistency is its only rule. You can try to change the past, but you'll only ever do what already happened. And then there's the most mind-bending possibility of all. The moment you interfere, the universe splits. You don't change your past. You create a new one. A branching world. A new timeline. A fork that moves forward without you. You're stuck in it now. A ghost from a different history. Your original world moves on without you. Unchanged, unreachable. And the more you think about it, the more the blade in your hand starts to feel like something else entirely. A test of reality's willingness to let you choose. Some ideas don't end in mystery. They end in contradiction. The kind that doesn't just confuse, it unravels. That's what happens when you follow the grandfather problem to its final breath. Because no matter how you try to twist the outcome, it doesn't hold. You travel back. You stop the birth that leads to your existence. But if you succeed, you erase the one who took the trip. The action negates itself. A perfect loop of cancellation, a story that deletes its author mid-sentence. This is the nightmare of causality. And unlike poetic paradoxes or theoretical folds, this one doesn't quietly loop. It explodes. Physics hates it. Logic rejects it. Yet the possibility hangs in the air, because time, in all its elegance, might allow motion backward. What it doesn't seem to allow is contradiction. That's why many scientists propose a kind of narrative repair mechanism. Some call it self-consistency, others call it cosmic censorship. But the idea is the same events may wrap and loop, but they can't break each other. You can go back, but only to play your part in the story that already exists. Try to step off script, and the universe pulls you back. You meet your grandfather, you raise your hand, but something stops you. A coincidence, a twist, a failure. It doesn't even have to be dramatic. It just has to make the contradiction disappear. You don't get to change the past. You become part of it. This makes time travel less like control and more like choreography. You can move freely, but only along the lines already drawn. You're not breaking the story. You're fulfilling it. But if that's true, if paradoxes are simply impossible, then free will becomes paper thin. Your choices may only exist if they've already fit into some unbroken loop. There's no risk of destroying time, because time already knows what you're going to do. And yet, the contradiction lingers. What if there's no repair, no resistance? Just a tear. One action too bold, one moment that logic can't wrap around. Then what does time shatter? Does a new branch grow, or does everything just stop? Somewhere buried in these loops and splits, there might be a deeper pattern. And maybe the reason the past feels so stable is because we haven't broken it yet. There's a strange idea hiding behind every paradox that the universe has standards, that it won't tolerate contradictions, that somewhere beneath the noise and chaos, there's an editor, quietly deleting impossible stories before they spread. Imagine time not as a straight recording of events, but as a self-writing manuscript. The rules aren't just about gravity and light. They're about narrative stability. And when something threatens to rip the story apart, a paradox, a contradiction, a grandfather dying too early, the timeline rewrites itself. Not with magic, but with constraint. In physics, this idea shows up as the Novikov self-consistency principle. The concept that any event occurring in a time loop must be self-consistent. In other words, time may allow loops, but never contradictions. You can travel into the past, you can interact, but you can't change the outcome. You can only fulfill it. It's not that you can't act freely. It's that your freedom is already written into the past you're trying to change. It sounds like fate. It feels like being trapped inside a script. A character who believes he's improvising, but is actually walking the exact same lines every time. This principle has eerie implications. It suggests the past is not just resistant to change, it's immune. Try to break it, and you'll find the gun jams, or you miss, or you get stopped. Not because of magic, but because of logic. Because paradoxes can't exist, and the universe has already accounted for your failure. But what if, instead of editing the timeline to avoid paradox, the universe allows a split? This is where things fracture. Some models propose that a contradiction doesn't get fixed. it gets isolated. You create a new timeline, a parallel stream of reality where your impossible action plays out. The original timeline remains untouched, but you're no longer in it. You're somewhere new, alone, in a version of history that was never supposed to happen, and you can never go back. So either the timeline bends around your choices, or it breaks away from them. In both cases, something has lost the dream of absolute freedom. The deeper we dive, the more time starts to feel alive, not flowing, but thinking. And if the universe is really editing itself to avoid paradox, what happens when even the editor fails? You take a step, simple, meaningless. But what if that step, or the hesitation before it, splits the universe in two? One version of you keeps walking, the other stops. Two timelines, now branching forever. Not just a metaphor, not a narrative device, but an actual structure of the universe. Sprawling, infinite, and made from decisions you didn't know mattered. This is the many worlds interpretation of quantum mechanics. And it doesn't just suggest alternate realities, it demands them. At the quantum level, particles behave like possibilities. A photon doesn't go left or right, it goes both, until observed. A particle isn't in one place, it's smeared across outcomes. But when you measure it, you only see one version, one reality, one result. So what happens to the others? Many worlds says they happen too. Every outcome is real. Every possibility is realized. But not here. Somewhere else. And if this applies to particles, it applies to you. To every moment you faced a choice, big or small. Every word you said or swallowed. Every person you met or missed. Somewhere out there, you are all of them. It's a haunting kind of freedom. Because now your life isn't a straight line. It's a tree, endlessly branching. Your regrets are real somewhere. So are your triumphs. So are your losses. So is the you that never came to be. And when you imagine going back in time to change something, to fix a mistake, save someone, undo a decision, you're not overwriting the timeline. You're creating a fork. A new path splits off, and you're walking into it. The past remains untouched, but you can never return. This solves the problem of paradox. You can kill your grandfather in that timeline, but your original self, the one who took the trip, still came from a world where he survived. The contradiction dissolves into a detour, but now the stakes change. Because every action has consequence, not just here, but everywhere. Every choice echoes into its own universe. And if that's true, then you've already created countless realities with thoughts you barely noticed, with moments you barely remember. The choices don't stop. The tree keeps growing. And somewhere, right now, another you is wondering if you made the better choice. Imagine waking up and feeling like something is slightly off. The room is the same. Your memories are intact. But you can't shake the feeling that a decision, maybe years ago, maybe yesterday, went differently than it should have. That sensation, that eerie dislocation. It might be nothing, or it might be the echo of a nearby reality. A version of you that chose differently and is now living a life you'll never see. In the many worlds view of reality, you are not a single thread of consciousness. You are a node. One observer among infinite versions of yourself, each riding a different branch of the quantum tree. And the strange thing is, The you that's reading this right now might not be the original. Because once the universe splits, all branches are equally real. No timeline is more true than the others. They all unfold with the same weight. The only difference is, this is the version you remember. But memory is not immune. In some interpretations, even your awareness may shift, subtly, slightly, as reality forks. You don't notice the change. You feel continuity, perhaps deep inside. Something in you recognizes that you made another move. And now they're watching from a different branch. Quantum computers already work with these ideas, running calculations across superposed states, using entanglement to process multiple outcomes simultaneously. It's not magic, it's physics. And it suggests the mind itself might not be a closed loop, but a spread, like a song playing across harmonics you'll never hear. And maybe that's what déjà vu is. Maybe that's what dreams are. Maybe we are constantly brushing up against the edges of the choices we didn't make. If that thought landed somewhere deep in your chest, like a memory you've never had, like a version of yourself blinking through the dark, they're probably not the only version of you watching this right now. Because you didn't just pick a path. You became one. Take a box. Seal it tight. Inside, place a cat, a small radioactive atom, a vial of poison, and a trigger mechanism. If the atom decays, the poison is released. The cat dies. If it doesn't decay, the cat lives. You don't check. You don't peek. You wait. Now, here's the question before you open the box. Is the cat alive or dead? Logic screams one or the other, but quantum mechanics disagrees. In this setup, the atom is in a superposition decayed and not decayed. And because the mechanism depends on that atom, the cat is now entangled with it. It, too, exists in a strange limbo, both alive and dead, until you look. This is the heart of one of the most infamous thought experiments in physics, not because it's gruesome, but because it reveals something deeply unsettling, that observation doesn't just reveal reality, it decides it. Before you observe, the cat is a quantum blur of both outcomes, alive and dead. Two paths simultaneously real. But the moment you look, one becomes your reality, the other fades. But where does it go? In the many worlds view, it doesn't disappear. The moment you open the box, the universe splits. In one branch, you see a living cat. In the other, you find a corpse. Both outcomes are preserved, not just in theory, but in structure. Somewhere, there is a version of you grieving. Somewhere else, there's relief. And you, the observer, are the dividing line. It's not just the cat in the box. It's every moment of uncertainty, every coin flip, every crossroads, every time you waited for the test result, the phone call, the yes or no. Each one was a branching point, a box you didn't open until it was already too late to undo. And in this world, you only get to see one outcome, but the others, they're still unfolding. This isn't just a physics problem, it's a mirror. And maybe the scariest part isn't whether the cat is alive or dead. It's knowing that somewhere, it's both. A cat in a box, a particle in a cloud, a decision unmade. In quantum mechanics, these aren't just moments of waiting. They're moments of suspension, where outcomes don't just sit side by side. They exist that way, at least until someone looks. And here's the twist that still rattles physicists: the moment of observation doesn't just reveal what's there, it finalizes it. locks it in, collapses the wave of possibilities into a single, solid fact. But what if the thing that causes the collapse is you? Not your eyes, not the device. Consciousness. It's one of the most disturbing ideas buried in the foundations of physics, that the observer isn't passive. You're not just watching the universe unfold, you're a participant, a trigger. The act of witnessing decides what was real all along. Some call this the measurement problem, but calling it a problem doesn't make it go away. The equations are clear before measurement. Particles don't have definite positions, they exist in overlapping states. Only when something, observes, does the system snap into a single, classical outcome. It's like reality waits for you. Not politely, not patiently, but fundamentally. This raises a question most physicists try not to ask too loudly. What is observation? Is it just data, a sensor, or is it the presence of awareness? If the answer includes consciousness, then suddenly you, the one asking the question, become the central mechanism. You're not a background character in the universe. You're part of what builds it, collapses it, shapes it. And if you collapse the wave function, what are you doing every time you choose? Maybe you're not choosing at all. Maybe you're selecting a version of reality that already existed, and the others fall away behind you, like echoes you'll never hear. If that makes your own thoughts feel like instruments, like tools of creation rather than observation, like maybe the very act of wondering carves something into the cosmos, then maybe that's what the cat was waiting for all along. Not science, not fate, just you. Take two particles, create them together in the same moment, under the same conditions, then separate them. One goes left, one goes right. Light years apart, entire galaxies could fit between them. And yet, measure one, and the other reacts instantly. It's not just fast, it's faster than light. Too fast for any signal to pass between them. Too fast for any message to warn the second about what just happened to the first. This is entanglement. And it might be the strangest thing quantum mechanics has ever shown us, because once two particles are entangled, they behave like one system, no matter how far apart they are. Their properties aren't just correlated, they're connected. Change one, and the other's state is instantly determined. Einstein hated it. He called it spooky action at a distance. He believed there must be something hidden, some variable we couldn't see, that explained this weird synchronicity. But every experiment said otherwise. Bell's theorem, and the countless tests that followed, crushed the dream of hidden variables. The universe really is non-local. Entangled particles behave as if distance doesn't exist, as if information doesn't need to travel because it was never separate to begin with. Now, think about that. Two particles that used to be one, still behaving like one, across space, across time. And here's where it gets uncomfortable. Because if particles can stay linked across the void, why not systems? Why not minds? What if every interaction, every touch, every moment of shared creation leaves behind a kind of entanglement, invisible but real? What if entanglement is the rule, not the exception? Then space itself begins to feel thinner, less like a barrier, more like a surface stretched between moments that never really broke apart. You are not alone. You are never unconnected. You are part of a web older than light. And if that changed how you feel about distance, about time, about separation, about what it means to be apart, then physics just showed us something we can't explain. And maybe what binds the universe isn't force or mass or charge, but memory. Let's say you throw a book into a fire. The pages blacken, curl, and vanish into smoke. But the words, the meaning, the information isn't truly lost. Not completely, in principle. If you knew every molecule of ash and air, if you could rewind every photon, you could recover it. You could reconstruct what was there. That's how physics works. Energy transforms. Information persists. Nothing is truly erased. Except, what if that's not always true? Now, picture a black hole. You drop something in a book, a spaceship, a person. The event horizon swallows it. No signal escapes. No trace returns. From the outside, all you ever see is the black hole growing slightly more massive, slightly more distorted. And here's the terrifying part, according to the classical view. The information about what you dropped in its arrangement, its story, its structure is gone. Not just unreachable, destroyed. This is the black hole information paradox. Because according to quantum theory, information must be preserved. It's the bedrock of how everything works, from the tiniest particle to the edge of the cosmos. But black holes, under general relativity, don't care. They take it, crush it, and hide it behind an invisible boundary from which nothing escapes. So which law breaks? Decades of argument followed. Some said the information is lost forever. Others said it must leak back out, encoded somehow in the radiation that black holes emit as they slowly evaporate. But no one could prove it. It's not just a question of astrophysics. It's a question of what can be known. If information can be destroyed, then so can meaning. So can memory. So can you. What if the universe has places where the rules vanish? Where knowledge enters and nothing, not even the ghost of it, survives? Maybe the black hole isn't just an object. Maybe it's a boundary. The edge of reality's ability to keep its own story straight. At the edge of a black hole, even truth can slip away. And maybe the most terrifying thing isn't falling into the void, but knowing that no one will ever know you were there. A black hole evaporates, slowly, relentlessly, over eons. It radiates away mass, a whisper of heat escaping from its edges. This is Hawking radiation, predicted decades ago, still unconfirmed, still unnerving. Because if it's true, then black holes don't last forever. They fade. Until one day, they vanish. Gone. Without a sound. No explosion. No trace. Just a slight ripple in space-time. And then, nothing. And here's the deepest fear if everything that fell into it, light, matter, thought, structure is gone too. Then the universe just lost something it can never get back. A page was torn from the cosmic book and burned. This isn't just about stars and gravity. It's about the foundation of physics. Unitarity. The idea that the information about a system's past is never destroyed, just transformed. The equations demand it, but the black hole seems to ignore it. Its evaporation looks clean, sterile, as if the universe itself is slowly forgetting something. And if enough of these vanish, what does the cosmos become? A place of empty silence. No structure, no record, no imprint of what once was, not even a shadow. The black hole information paradox was never just a question of physics. It's a question of identity. If the universe can lose information, can it lose us? Some theories try to solve this, that information is stored on the event horizon like a hologram. that it's smeared into radiation as the black hole evaporates, that it's hidden in correlations too subtle to detect. But we don't know. We still don't know. And maybe we never will. Because this is where science meets something darker, the idea that reality itself may not remember everything. That some stories, entire galaxies, entire lives, might fall into silence with no echo, no footprint, no way back. It makes the question bigger than survival. It becomes legacy. What do we leave behind if even the universe forgets? Some paradoxes aren't about confusion. They're about grief. And maybe the universe won't end in fire or ice, but in forgetting. Somewhere along the line, we started believing that anything could be known, that the universe, no matter how strange or vast, would eventually give up its secrets, that science, given enough time and tools, would explain it all. But what if that belief is just another illusion? What if there are places in reality we were never meant to reach? Not because they're hidden, but because they can't be known. Every paradox we've explored: time loops, vanishing information, superposition collapse hints at one brutal truth. Our minds were shaped by evolution, by survival, by a need to make sense of the ordinary, not the infinite. We're built to find patterns in bird songs and faces, not to parse 12-dimensional Hilbert spaces, not to intuit a universe where one event creates two timelines or where causality flows both ways. So we reach, we model, we simulate, but we're still watching shadows on the cave wall. Reality remains behind the curtain, and every time we peek, the light burns our eyes. What if the reason these contradictions persist, these loops and disappearances and impossible decisions, is because we're trying to force logic onto something that was never logical to begin with? The universe may not be broken. Our perception might be. There's something unsettling in that thought. Not just that we don't know, but that we might never be able to know. That our questions hit a wall, not of science, but of mind. That reality is too large, too recursive, too alien for brains wired for beginnings, middles, and ends. And yet, we ask anyway. Maybe that's the most human thing about us. Not intelligence, not memory, but the willingness to stare into a problem that refuses to resolve and keep staring. If your mind feels tired, but strangely awake, like it just ran into something too big to hold, this journey isn't about answers. It's about staring at the boundary between understanding and mystery, and the haunting possibility that beyond that boundary, there's only silence. What if we're not late? What if we're early? We often imagine ourselves as the newcomers in a galaxy already full of ancient civilizations. The silence then becomes eerie, suspicious, a mystery to decode. But what if there's no one else to decode it? Not because they're hiding, but because they were never here. In that version of the universe, we aren't just curious. We're alone, not by accident, but by chronology. Ours might be the first spark of self-awareness to ever rise from the dust. The first time the cosmos has looked inward and asked, "What am I?" That idea changes everything. Suddenly, we're not explorers. We're origin points. The first voice in an empty cathedral. The first pattern of thought. The first hands to build machines that dream. And with that position comes weight. A terrifying kind of responsibility. Because if we are the first, then what we do matters more than we can possibly understand. We're shaping not just our future, but the blueprint for what intelligence can be. Our survival or our failure becomes the prologue to all consciousness that may follow, or the final chapter of something that never had a sequel. And the silence, it stops being ominous. It becomes sacred. Not a warning, but an invitation. A vast, untouched space, waiting for its first story. But what kind of story will it be? A species that builds until it forgets why it began, or one that learns, adapts, reaches, and speaks? We may be standing at the beginning of something that has never happened before. And the first mind to awaken in the void has the power to shape everything that comes after. All of this, the science, the paradoxes, the vastness, eventually circles back to something personal. About you. About the soft, temporary body sitting in front of this screen, listening, wondering. Because underneath every theory, every telescope, every machine, is a mind trying to outrun something death. We rarely admit it, but our hunger for knowledge, our obsession with time, our need to leave something behind, it all points in the same direction. We are the only creatures, as far as we know, that fully understand we're going to end, and we don't accept it. So we imagine other timelines. We theorize about uploading consciousness. We ask if the soul can travel through space-time. We wonder if intelligence, once born, can ever truly die. And here's where it gets strange. The same physics that suggests particles can entangle across the galaxy, that time can loop, that information can vanish into silence, also leaves room, just barely, for something beyond finality. Maybe death, like measurement, is not an end. Maybe it's a change in state. Some scientists and thinkers have speculated that consciousness could be a pattern, something that, if copied or transferred, might persist. Others imagine minds running in simulations, a digital afterlife built from code and memory, a dream that never ends because it was never tied to cells in the first place. And then there are the quieter theories. Ones that say, maybe this is the afterlife. Maybe the fact that you're conscious right now means you always will be. Not in this body, but in a body, somewhere. It's not proof, it's not comfort, but it's not nothing. Because physics hasn't ruled it out, and mystery hasn't gone anywhere. If that made you feel the weight of your own breath, and the brief, bright moment of existing, science may not give us eternity, but it gives us the tools to ask whether forever was ever ours to begin with. And maybe the desire to live forever isn't about escaping death, but about finally understanding life. The universe is expanding every second. Galaxies drift farther apart. Space itself stretches quietly, relentlessly. And as it does, the stars grow dimmer, the sky emptier, the night colder. It won't happen tomorrow, or in a million years. But someday, the lights will go out. The last stars will burn through their fuel. The last black holes will evaporate. Matter will decay. And what's left won't be silence, but stillness. Absolute stillness. No warmth, no motion, no thought, just cold. This is the long view, the heat death of the universe, a future where entropy wins, where everything useful, everything structured, everything alive, dissolves. But here's the paradox: if it all ends in nothing, then why did anything begin? Why emerge from that stillness only to return? Why produce consciousness only to watch it vanish? Why spend billions of years assembling stars, molecules, minds, for a story that ends with a blank page? Some say the universe doesn't care. It has no reason, no plan. It simply is. Others wonder if this echo, this final stillness, is part of something larger. Maybe entropy isn't death. Maybe it's a reset, a coiling spring before another beginning, a deep breath before another big bang. Or maybe this is the only round, and the echo we're hearing isn't from the end. It's from us. Our questions, our hopes, our attempts to write meaning into a system that never asked to be understood. Maybe the echo isn't from the edge of time, but from our own need to matter in a universe that keeps whispering back. You are temporary. Still, we listen. Sometimes. Science doesn't answer the question. It is the question. And maybe the echo at the end of time is the sound of something that once dared to care. We've talked about black holes and time loops, multiverses and information loss, cats that are dead and alive, observers who shape reality, machines that learn to think. But beneath all of it, every contradiction, every mystery, something has been quietly watching you. Not as a bystander, not as a narrator, as the paradox itself. Because here you are, aware, wondering, temporary, infinite. A creature built from dust, asking questions no stone ever asked. You contain atoms that came from stars that died before Earth was born. You think in language that evolved from grunts and firelight. You imagine your own end, and you keep going. That shouldn't be possible. You're built from parts that don't care about you, blind molecules, mindless energy, systems that follow rules, not dreams. And yet, somehow, from all of that, you emerged, not just breathing, thinking. And here's the cruel wonder, no matter how far science stretches, no matter how many dimensions we unfold, how many timelines we map, how many equations we balance, the thing we understand least is the one asking the questions. What are you? A signal riding a nervous system, a flash of organized matter, a glitch in biology, or are you the universe's answer to its own silence? We'll never know for sure, because every answer folds back in on itself. Every path loops. Every truth becomes a mirror. You are not outside the mystery. You are inside it. And maybe that's what all of this has been about. Not to solve the paradoxes, but to realize that you are one. A mind that can't explain itself. A being aware of its own disappearance. A voice echoing through a universe that may never reply. And still, you ask, maybe the last paradox isn't out there in space or time. Maybe it's here, now. The impossibility of you. And that's where the story ends. Or maybe where it begins.